Sir, unusual times.
Unusual.
Unusual times. ये भी 2020 भी देखना था हमें. Heard about lots of pandemic, Spanish flu and all, but this time we are experiencing this.
Yes, correctly said. So, Dr. Purohit, recently you must have visited the PRL. आपका sound.
Actually, our department has just started. All the faculties are new from 2018. Everybody is new, and all the 10 faculty members are new. We have recently got some projects under RUPA grants, and we are trying to establish a lab, some labs there in the department, and maybe in a couple of years we will be in good position to have some good results.
Okay. Yeah.
We will certainly require your help and guidance in establishing the labs.
Of course, we have very good experience, so you should use that.
Yes.
It is kind of opportunity, and you know that we are having interaction with your university. Our students are registered in your university.
It was earlier, but it is not stopped now.
It stopped, but how does it matter? Because now the department is new, so you can initiate this kind of collaboration again.
Collaboration was there, but earlier our university used to have your study in our department in our university.
Yeah.
But now
Regulation in PRL or regulation in university?
UGC regulations from Government of India.
I know BSIP people, they are all registering with Lucknow.
But now candidates for PhD only in its purview area or administration area. They cannot go beyond their administrative capacities.
I know.
So they are supposed to have are supposed to have the students registered in the administrative area only.
Yeah, because
Okay, so this is new guideline, eh? So that means now
2015.
2015. Okay. See, nowadays
we are now always limited. We cannot register students from outside our area. They are trying to have some MOUs with your lab.
Yeah, that is what we have to find out some way.
Yes, sir.
I think if PRL and your university, your department, they initiate some kind of collaborative work, some interactions are. Then if there are interactions, then only you use some pros to avoid all these kind of things.
Sure, sir. We will try to have an MOU with your lab for research collaboration.
Yes. In that way, I think it can be taken care. Currently, our students are registered in IIT Gandhinagar.
Yeah, IIT Gandhinagar or maybe in Gujarat University.
Mostly they are registered in IIT Gandhinagar. No, Gujarat University only.
Yeah, Rajesh Agnihotri degree I have seen from Gujarat Vidyapit.
Rajesh Agnihotri may not be from Gujarat Vidyapit. He should be from Gujarat University.
No, he was from PRL.
Yeah, but I am surprised. I do not know how he's also Gujarat Vidyapit.
No, his degree must be awarded from there.
Okay.
He was working in PRL only, no?
Yeah, he was working in PRL.
Who is this student or Bhattal or something?
He worked with Professor Krishna
Somya,
Swami.
Somya Julu.
Yeah, and then
Yes,
Somaya Julu, yes.
And afterwards with Krishna Swami sir, I think.
Okay.
He worked with Bhattacharya also.
Hmm.
Yeah.
These old timer keep coming to PRL or no? Sareen, Bhattacharya.
Sareen is still, he comes.
Okay.
Okay. And Bhattacharya, he is, I think, in Taiwan currently.
Okay.
Oh,
So only
with-
Sareen,
I think
Sareen Saab is the senior most person who is still associated.
Shashadhar
Yeah,
is also at Taiwan, sir, na? Shashadhar?
Who?
That's the- Yes.
He did PhD with Bhattacharya sir.
Hmm.
Yes, Ankush.
Sorry for the inconvenience, sir. Actually, there was some technical glitch in the YouTube channel, so we generated another YouTube link and circulate mail it to all the participants of this webinar. So that is why I was taking 10 minutes break for that. Now all the new link was sent to all the participants. Now I request our head of the department, Dr. Ritesh Purohit sir, to welcome our distinguished speakers and give their introductions. Ritesh
मैडम
sir.
मैं बाद में बात करूंगी मीटिंग चल रही
Honorable honored invited speakers, Professor Nigam sir, Professor Yadva sir, and Dr. Ashutosh Singh, delegates, faculty members, scholars, and students. I have a feeling of enormous pleasure to welcome you all through this webinar on the occasion of completion of 7 decades of our department, which was established in 1950. Department is one of the oldest PG departments of sciences, not only in Rajasthan, but almost all over the northwest India. It has a prolonged prestigious history once since its inception. Department has established its image of one of the pioneer departments in the field of earth sciences in the entire country. Department began its success history under the aegis of Rajasthan University, Jaipur, and later was merged into the Mohanlal Sukhare University, Udaipur, from the session of 1988-89. Since then, it has worked in coherence with the other departments and faculties of the Sukhare University for nearly 30 years. The department has mainly produced many alumni who have brought glory to the department, as 16 of them are National Mineral Awardees, and many of them have worked as directors, presidents, chairmen of leading organizations of India in the field of geology. High quality of renowned research work has been another feather in the cap of the department in the form of international and national books, high quality research papers in reputed journals, award of SAP and FIS programs by UGC and DST respectively, organization of many international and national seminars and symposiums. Present webinar is one such step in our march towards excellence, as we are now beginning all new with the induction of 10 new faculty members from 2018 onwards and trying to leap forward with the fresh energy. Webinar is titled as Proxies on Climate uh, Proxies on Climate Reconstruction. The aim of the seminar is to improve our understanding towards climate changes on geological time scale and use of various proxies to reconstruct paleoclimates. This is one of the applied and most studied field of our sciences in broader perspectives, and researchers are going worldwide to understand the climatic changes with the help of paleoclimatic reconstruction. I would like to congratulate Dr. Ankush especially picking up such an important research related issue in applied geosciences. We have got with us today 3 leading speakers on this issue from the country who will enlighten us with their knowledge and experience. It is an honor and privilege to introduce Dr. Rajiv Nigam, former Deputy Director and Emeritus Scientist at National Institute of Oceanography, Goa. Over the years, he has received many awards, beginning with the CSIR Young Scientist Award, National Mineral Award from the Ministry of Coal and Mines, Krishna Medal Award from the Indian Geophysical Union, H.N. Siddiqui Memorial Lecture and Medal from the Indian Geophysical Union, and also the S.N. Bhalla Gold Medal awarded by the Paleontological Society of India for his excellence in micropaleontology. He has to his credit over 100 publications in national and international journals and has guided 15 students for their doctoral degree. Professor M.G. Yadva is from Geosciences Divisions of PRL. He obtained his PhD from Devi Ahilya Vishyavidhalaya, Indore, based on the topic of paleo monsoon reconstruction. He has about 30 years of research experience in the measurement of radiocarbon in terrestrial environment samples and in stable isotopes in carbonates, cave waters, and rainwaters. The major thrust of his research activity is to discern the signatures of past climatic changes as recorded in speleothems, sediments, and archaeological archives. He is currently involved with the Accelerator Mass Spectrometer AMS facility for radiocarbon dating and laser absorption spectroscopy LAS for isotope ratio measurement in water and ambient vapor. Dr. Ashutosh Kumar Singh was recipient of prestigious gold medal in the field of micropaleontology and oceanography at BHU. Dr. Singh made his significant contributions as postdoc and published high-quality research papers in international journals. He worked on the course of Oman margin and derived important conclusions about evolution of Indian monsoon during last 20 kilo years. He presented his findings on paleomonsoonal records at AGU fall meeting at San Francisco, USA. Being an active oceanographer, Dr. Ashutosh participated in international oceanographic expeditions on board research ship Marion Dufresne in the senior in the Indian Ocean. Dr. Ashutosh joined Department of Geology, Delhi University as faculty in 2009. At present, he is senior assistant professor at University of Delhi, and important contributions include establishing the late Neogene planktic foraminiferal biochronology for the Eastern Indian Ocean using biostratigraphy and magnetocronology, establishing teleconnections between northern hemisphere glaciations and faunal turnover in Eastern Indian Ocean, and many others. I again wholeheartedly welcome all three of you. I sincerely hope that participants of this webinar will be highly benefited by your deliberations. I sincerely wish to thank the honorary committee of the webinar, Dr. Anjali, Mr. Akhil, and Mr. Niranjan. Now I hand over it to the convener.
Thank you, sir. Thank you for your welcome speech and giving introduction to our distinguished speakers. Now I welcome Dr. Rajiv Nigam, sir, former Deputy Director and Emeritus Scientist, National Institute of Oceanography, Goa, to kindly deliver his talk. Sir,
Okay, I will share my slideshow first.
okay.
And once it start, please let me know that you can see. Then I will start talking on it.
Sure, sure. Sir, your screen is now visible to all of us.
Okay.
So your slide is visible.
Okay. So I have to now see my slide and talk because I can't see all the beautiful places on the screen. So this is a new experience I am going through after the lockdown has come. So first of all, a very good morning to all of you. Professor Amrika Singh, the Vice Chancellor of the University, Professor Kanika Sharma, the Dean of the Science College, Dr. Ritesh Purohit, Head of the Geology, and the organizing team, Dr. Ankush Shrivastava, Dr. Anjali Singh, Mr. Akhil Trivedi, Mr. Niranjan Mohanty, and my co-presenters, Professor M.G. Yadav and Dr. Ashutosh Singh. Welcome to all of you for today's webinar. Before I start, because every time we cannot bring the new topic, and this is mostly aimed to the students. So if someone has seen it, please excuse me. I to speak of about 45 minutes. See, today's topic is the role of foraminifera in study of the past monsoons, sea levels, tsunamis, and archaeology. If you see the title of the webinar, the proxies in climate reconstruction. So there are few words like climate, that is reconstruction, and foraminifera, and then few of the parameters of the climatic variation like monsoon, sea level, tsunamis, and archaeology. What is the climate? Climate is nothing but the energy balance. But before I go into the detail of climatic fluctuations, I will introduce my institute first. This is the National Institute of Oceanography at Goa. The institute deals almost every branch of the science and trying to apply these branches to enhance our understanding about the sea around us. There are respective divisions like geology division, biology, chemistry, physics, marine engineering, archaeology, and so on. We'll be talking about what we do at Geological Oceanography Division, particularly the paleontology and construction of the reconstruction of the past climate and archaeology. I put a slide of archaeology, how the understanding of the past climate through foraminifera is applied to explain some of the important archaeological findings of our cultural heritage. This is foraminifera. Now let us start the formal presentation. Friends, when you open the newspaper in the morning, you are always flooded with this type of news. We'll see under the water, Panjim, which is the capital of Goa, is the next. This is a Navin Times Panjim paper. Everywhere, whether it's a newspaper or whether it is a TV show, daily you will get some news and everybody is talking about what is happening to our climate. See here, I put a cartoon which I'm using it for last many years. This is one of the very favorite cartoon, and almost I use it in all my presentations. This is the Mother Earth, and Mother Earth, you can see, is in tears because the protective umbrella of the atmosphere has been punctured by its own son, the man, and therefore we are facing a lot of problem about the global warming. See, we all talk about global warming, which is associated with the enhancement in greenhouse gases. See, the greenhouse gases are good for us because they allow the sun, the energy from the sun, which comes in short wave, the earth radiate back energy, which goes into the long wave, and part of this energy has been trapped by the atmosphere, and therefore earth is warm. Because earth is warm, there is a life on it. If you remove all the greenhouse gases, no life is possible on the earth. But we say that excess of anything and everything is bad, so is the greenhouse gases. We started pumping in more greenhouse gases into the atmosphere as an anthropogenic effect. And therefore, earth is warming. Now, there are various consequences of the warming, global warming, where an oceanographer is concerned. That is the accelerated rise in sea level. This is because of the melting of ice into the polar region and the thermal expansion of the seawater, which is likely to enhance the sea level. And the further consequences about loss of land and other things, which is the further chain. Second is the change in the monsoon pattern, because India by and large get the rainfall during the monsoon, on which our economy through the agriculture is depending. This is also likely to change if temperature pattern is changing. Then coastal people are suffering with this storms. So there is likelihood of increase in the intensity and frequency of the storms. And also the most favored product of the sea, the fisheries are also likely to be affected if there is going to be a global warming. Now, the question is, when there was no man on this planet, and if man is only responsible for the climate change, climate should not have changed. But we know that climate has changed many times on a different time scale. See, you can see, for example, the sea itself. Many times the sea level has gone even above the present level, and sometimes it was lower than the present. A big part of the Trishnapalli, the Tamil Nadu was under the water, very famous Cretaceous transgression and regression of the sea is concerned. A part of Surat and Bharuch was also. Not only this, the biggest, the highest mountain on the earth, Himalaya, was also once upon a time was sea, the Tachish Sea. But if we want to see about its effect uh, on the man, we are more concerned during the Holocene how the climate has changed. Therefore, there is a growing need to delineate the natural and human-induced changes. Therefore, efforts are being made to reconstruct the natural climatic variability over which the man influence can be evaluated. So unless, for example, if sea level is naturally going up and because of the greenhouse effect is going up, it means problem is compounded. But if sea level is going down and because of anthropogenic changes going up, it may be nullified. So it is always good to know the natural climatic variability in last few thousand years, which are very important for the human civilization. So let us see how to reconstruct the past climatic variability using the sea. So the thrust is to enhance the understanding of past climate changes through the study of microfossils, which serve as a proxy, which is the in the title of the webinar today. So with special reference to foraminifera in the marine sediment of the Indian Ocean and the adjoining seas. How marine sediments archive the changes in the climate. So let us see how we do the sampling in a very simplest way. See, friends, if this is the land and if this is the sea, now we sea receive the sediments in two ways. Either it is coming by the water or coming by the wind from the land. In addition to that, there is a lot of the animals of various size, micro to mega, they also live. And after their death, the hard part of this shells, as well as in the sediments, they're deposited layer by layer, year by year at the bottom of the sea. And now these animals which live in balance with the ambient water, they hold the signature of the past climatic changes. So we have to study the layer by layer, this microfossil, how to collect it. We can take our ship, then through the wire rope, we sent the corer, which core this, and it comes from the lab, and it can be studied by many branches, whether it is sedimentology, geochemistry, petrology, paleontology. Everyone try to study these sediments to unravel the history of past climatic changes. Now we use it, the microfossils. The main group of microfossils, you know, many of the students of geology, that are based on the composition, we classify the microfossils into calcareous, siliceous, phosphatic. Conodonts are no more exist now. And the organic wall microfossils. Today, I will tell you example how microfossils can be used to solve a variety of problems related to the climatic reconstruction. And they hold the key for the future climatic changes. Now, all these microfossils in some way or the other can be used for climatic reconstruction. So if you understand the process, how how to use microfossil. Does not matter if you are not working on foraminifera. You can work on nanoplankton, you can work on osteochord. Actually, I'm very fond of the osteochords because osteochords are found everywhere almost. Okay, so this is another very promising tool which is coming up. Nanoplanktons are radiolarian mostly find into the deep sea, and then diatoms, silcophilids. Lot of work is going on, and the palynology. So let us see about foraminifera. First, let us in few words understand what the foraminifera are. See, there are two types of foraminifera. One is the planktonic foraminifera, which will live in the water column, and the one which live at the bottom of the sea. When they live, they secrete the calcium carbonate in equilibrium with the seawater. So they incorporate the composition of the seawater and the other environmental factor like temperature, salinity, EH, pH, and we can make use of these microfossils. Now, another thing is most of these microfossils, the foraminifera, they are less than a millimeter in size. Their fossils are exclusively marine organisms. Remember this. They are exclusively marine organisms. They are highly sensitive to the climate change. A slight change in any of the parameter in the climate, there is a big change either in the morphology of the test or into the abundance of the species, what we call it the census count, or the assemblage itself, which is changing. Even the life of some of the species are also changing depending upon the climate change. So how they look like, few of them here, and remember this property. And this planktonic foraminifera are more abundant if you move away from the coast. There is benthic foraminifera right from the, you can say, interaction of land and sea to the sea, and they are very prominent till we reach to the CCD, the calcium carbonate compensation depth. After that, only very few benthic forms in keel of the planktonics we get it. Other forms they get dissolved. You can see here, uh, these are the benthic forms. About more than, I think, if I count more than 2,000 species, already we have identified from the uh, Arabian Sea and Bay of Bengal. There are more than 10,000 species which are very dominant into the various seas. And these are the planktonic foraminifera. You can see a very basic difference. Here, if you see, they have a large, most of them have a large pore, and it looks like a balloon put together. So because of the weight versus volume, they live in a water column, able to live. And because of their climatic sensitivity, we have used them into the variety of applications. Almost every problem associated with the marine environment, we are in position to give the first order interpretation or the solution. Let us start with it. It's a paleoceanography. Petroleum exploration. Petroleum exploration is a textbook example, and right from BSc and MSc, we have been taught in our classes how they are useful in petroleum exploration. And it is the petroleum industry which has given a lot of funding in the beginning of the development of paleontology, particularly the foraminifera. Then there is a sediment transport direction we can interpret, which is basically an engineering application about the stability of the any offshore structures like the Bombay offshore platform, their pipelines and effluent disposal pipelines, oil transportation pipelines. There we can also use the foraminifera. The monsoon variation, how the rainfall has changed in last few thousand years, and whether they give any idea about the future, it comes under the monsoon variation. Sea level changes, how sea level has changed in the past, and its application mostly the changes in monsoon and the sea level collectively give you idea about the marine archaeological problems. I will take up some of the problem and some of the and the paleo tsunami. Also, we can find out the history of last tsunamis by studying the foraminifera. Two latest application what we have developed is their application in finding about the variation in the fisheries, and also the pollution monitoring, which is another industrial application of foraminifera, and through which we are actually earning a lot of external cash flow in our institute. In view of the limited time available, I will try to touch up, but if you want, you can ask question in any of this branch, but mostly I will be dealing with monsoon variation, sea level changes, application in marine archaeology where forum have been used, the past tsunamis. So these four topics we are going to discuss today. Let us take one by one. This is a figure from Rajasthan. I think the people of Udaipur who knows, who comes from Rajasthan, the value of the water. Who knows better than them? And India, by and large, gets most of this monsoon either to southwest monsoon and little less in the northeast monsoon water. And our agriculture largely depend upon the monsoonal rainfall. Any variation in monsoonal rainfall, either in white floods or the droughts. And couple of drought years lead to the famine. And very infamous Bengal famine of 1940-45 is killed about 1 million people and equal number of cattle. So, and it have a very, very big impact on the economy of the country. Therefore, there is a persistent demand by the planner of the country whether monsoon can be predicted. Basically, the job done by the Meteorological Survey of India. Okay, there are a number of institutes and the India Meteorology Department. See, but problem is we have a very good record of 100-year rainfall. But if you want to have a long-term prediction, we need to enhance the length of the data. Unless we know a length of the data, 2,000 years, a very good prediction become very difficult. So there is a need to enhance our understanding of the past monsoonal rainfall. How to do that? See, some of the models have been developed on by the climate modelers. India is here. They say either where rainfall is increased or decreased. This is from a NATO series publication. But as I told you, they are all based on the last 100-year rainfall, which is not sufficient. So we have to enhance the length. So we have to go for a proxy. Now, how to develop? Many people have used foraminifera to reconstruct the monsoon record based on the planktonic foraminifera from the deep sea. Now, these are very good studies, but only problem is when you go to the deep sea, the rate of sedimentation becomes slow and your resolution becomes very poor. So when you are interested to know about change in the monsoonal precipitation over the 1,000 years scale, that work really provide a very good data. But if you want to enhance our understanding of past monsoon in last few thousand years, which is required for the predictive purpose, we have to work in the coastal areas where rate of sedimentation is high. So a core give a very high resolution record. Now this figure give us an idea how the coastal sediments can be used to reconstruct the past climate. If it is a live class, I ask what you make out of this photo. See, a river is joining the sea here. This is a sea water and this is a river water which is dry. So the river create a micro environment at its mouth, and this micro environment we have used. See, if more water rain is there, more fresh water comes and this micro environments go towards the seaside, and the layer which is getting deposited during this time is showing a brackish or a freshwater environment. But if a couple of years rainfall is very less, very little freshwater is discharged, normal marine water takes over, and the second layer which is getting deposited will have a more saline indicator, less rainfall through the sunlight. So if you take a core from here, And if you have a species which can indicate your salinity fluctuation, so you can reconstruct the climate: low salinity, high salinity, low salinity, high salinity, low rainfall, high rainfall, and just rainfall in the catchment area. This is a concept. Now, this concept needs to be tested first. This we tested is of Karwar, because a Kali river joining here, you can see a very big variation in the salinity at its mouth, even at the bottom, not only at the surface, even at the bottom. So what happened? This is the area. Now we know the concept. We decided the area. Now we have to develop the tools which indicate the salinity fluctuations. Now, so first, in order to develop a proxy, we have collected the surface sediment. If this, you see the surface sediment, we have collected the sediment and the two core samples and separated the foraminifera. Now, if you see this, see the foraminifera, each species is telling you the climate. But if you go for a species identification, many people get frightened when they see the thousands of species and you tell them, each with the big names. For example, this is species, Cuncloculina pseudoreticulata. The non-paleontologist or a BSc, MSc student get frightened. I have to learn the identification of thousands of species. So we develop, for first order interpretation, morphometric parameters. You need not go for the species level identification. See the morphology. They all are rectilinear forms, anglo-asymmetrical form, and these are all rounded forms. So you pick foraminifera from the sediment, calculate their percentage and plot it. Now you see here, the rectilinear forms are less at the river mouth. So more the rainfall, less is these forms. So this can be taken as a parameter for the rainfall reconstruction. Now what we have done, we have taken a short core at the sector 31, and we know the 100-year rainfall. So we have a 100-year rainfall record, and we reconstructed through the percentage of this microgroup, the rainfall record, and we can see that very well they are correlating with each other. Now we know the concept, we have the tools, and now we have tested the tools. Now with this tested tool, we have reconstructed the past climate, and you can see this is about 5,000-year rainfall record. It's a very high resolution record. About 80 years is the resolution here. If you see from here, the species is declining. It means the rainfall is increasing. And therefore, there is a boundary around 3,500 years. After that, the rainfall is decreasing, and the worst period was something around 2,000 years. You can see here. So it means monsoon. If monsoon is regular and not varying much, probably we should get a straight line here. So much fluctuation says that monsoon keep fluctuating in the past. And around 3,500 years back, monsoon rainfall was high, and around 2,000 years, it was quite low. You can see the lake level records also. Before 3,500, lake level was higher. And after that, the lake level is lower. So this also shows that, yes, and this is the geophysical record from where this core is collected. You can see this is a 3,500-year boundary. You can see that through the geophysical record, the speed, and this is the bottom of the sea. So the signature of 3,500-year boundary is found into the lake level as well as in the geophysical record. Later, it is supported by the oxygen isotope studies as well. And I would like to tell you more about this 2,000-year boundary. Most of the BSc and MSc student, if they're still reading the old book by Wadia, in the first chapter, you can see a sentence. Probably prior to the beginning of Christian era, means prior to the beginning of Christian era means before 2,000 years back. Before that, probably Thar was a well-cultivated land. It means unless rainfall was very high, it was not possible. Now you see, before 2,000 years, see this portion. The rainfall was very high. It means it was a regional cycle. So this is the when it was published, this is the best high resolution record. But if still you ask me, can you predict anything out of it? I will say yes, but I will say monsoon will be very good or bad after a few hundred years. Sounds good academically, but practical application is very limited. So we still need to go for higher resolution, and we have gone for another core, which is representing about 500 years. And if you see through the various parameters, you can see the cycle. This dry climate, it looks they are put into very regular interval. And if you see the rate of sedimentation and the dating of this core, the time between these two dry period is roughly about 77 years. It means there is a climatic cycle which is about 77 years. It means every after 77 years, there is a concentration of drought years. See, the people who are working into the deep sea, who are reconstructing the monsoon records, they could not discover this cycle because the cycle, their one sample itself represent about 100 years. Like I showed you my previous core, where resolution is 80 years. So it goes into the one sample. And the meteorologists could not discover this cycle because you need at least 3 peaks to tell a cycle, and the record itself is 100 years. So it was left to the paleontologists to discover the cycle, which is called the Glesberg solar cycle. Now, I will tell you, once you know this, there is a cycle, let us see the significance of it. This is a recently concluded Chhat Puja. Many of the ancient civilizations, they were worshipping the sun, because basically it is the sun which controls the climate on the earth. Sometimes when see, the anthropogenic change which we are talking now, we are trying to modify the outgoing energy. We are trapping more energy. That's why climate is likely to change. But climate can also change if incoming energy is becoming more or less. And this is happening on various time scales, from you can say few years to few decades to few century to few thousands of years. Milankovitch deals with a very long time framework, whereas we are interested in sub-Milankovitch cycle, and this 77-year cycle is related to the Glesberg solar cycle. The radius of sun in 0.1% of the arc changing at every about 80 plus minus 10 years. This is solar radius, and the solar radiation change the luminosity change the temperature change the rainfall. And this is all India rainfall, and this is the rainfall of the sector 34, about which we have presented the code. So this has showed that it is basically the sun which was controlling the cyclic nature of the monsoon. And after knowing the cyclic nature of the monsoon, let us see. See, this type of figure has been regularly published into the newspapers during the monsoon period. This is showing the less monsoon years, and this is showing the more monsoon years. Now, if you, this I put a freehand curve. This figure has been taken from the IMD records. And then you can see something around about 1900, 1905, and 1900, about 75, 80. Very bad monsoon is there. Many times, very frequently, the monsoon has the drought years. And this is within the error limit, the last 2 peak of 77-year cycle you can see. And now, if you want to predict, just extrapolate this curve, you can see probably from bad period here going towards a good period. Now, if this is true, see that how much implication it has. A good monsoon means a good economy. Good economy means a lot of development, less political problem, less interstate or inter-countries problem. Okay, so it's a good time. This currently we are going through this time. But see this, and there is no need to have a big problem about having enough water. Now, India and Bangladesh have enough water to share. Okay, there's less problem because nobody's talking about Farakka Dam now. But when the time comes, this one, the planner of the country can think that now rainfall is going to decline. We need more money to import maybe the food grain. We have to manage the drought. There will be a bad economy. So with the tiny foraminifera, you can get the idea about the coming years, and therefore you can help your country in planning about financial management. Now this study, we started long back, and now we are repeating it at different river mouths. Some of the students, those who are listening to this lecture, I welcome them to NIO, and then you can come and join our group to enhance this understanding. And see, this doesn't require any sophisticated equipment. With a simple plain binocular microscope and a core sample, you can talk about monsoon. Now you can further refine these results. You can convert it. That's what we are doing it at our institute into the quantitative. Right now, I'm telling you, going to be the good monsoon, but you can ask how much good. 10% more than the average, 20% more. So how much change? This answer can be given only when we go for quantitative study, and we are doing it through the magnesium calcium ratio studies as well as the isotope studies. I think Dr. Yadav, when he will give lecture, he will tell you how the different isotopes can also be used to refine the result, which are obtained through a pure paleontological studies. You can use the sediment also, you can use host records also, other microfossils, melanology to check this model about reconstruction of the past rainfall records. Now, another feature which has 2005 has created a havoc along the east coast of India is the tsunami. This is a figure of last few tsunami. And we Indians have a habit of believing more if somebody from the developed country tells something good about science in our country. So we invited Dr. Tarak Murthy and he came and he gave a statement which is published on September 29, 2005. And what he predicted about tsunami? The tsunami in the subcontinent follow a 60-year cycle during which the strain is built up in the earth crust. And what he tells, a second tsunami could hit India in November this year. But this time the killer wave could strike the Mumbai and Gujarat coastline. Now, his prediction has not come true. Why? Because he also based his results based on the history of tsunami in last 100 up to 100 years. So we have to get an idea about the past tsunamis. See, about tsunami, since most of the time it is associated with the earthquake, and people say that since earthquake cannot be very precisely predicted, so is the tsunami. I will tell you, students, we have already deployed the tsunami warning station in the Bay of Bengal. But from there, you can get few hours warning that tsunami is likely to hit at such and such time our coast. So you can transport your population. You can take safeguards so that less life and the property is affected. But you cannot get idea about say few years or few decades in advance. For that, you have to generate the data for the past tsunamis and try how to generate this data about the past tsunamis. See, this is because this Makran coast is a tsunami-prone coast, so we have collected samples near the Kori Creek area, and lot of surface. This is the work. See, the monsoon work was done by my PhD student, Dr. Nilay Khare, now who is in the MOES. Now, this work has been done by Dr. Subodh Chaturvedi. See, these three course results are very interesting. These are the three cores. And we have studied the foraminifera. We found that this branch have a very fine grained sediment and a fine foraminifera. Something very unusual which we are not expecting here. So we put the dating also here to find out what is there. And very interesting thing came. See here. 10,000 700, 800 year, 11,000 50 year, 11,300 year, 11,500 year, 12,800 year. See, and here you can see something around 8,000 here and 7,800 here. It means around 8,000 year, something happened, and this is the inverted sequence which is sandwiched into the normal sedimentation. And the sedimented thickness is more when you move away from the coast, and it is thinning out when we go towards the coast. So this need explanation. How? See, normally entire geology or paleoclimatic reinforcing is based in any core. Sediment at the bottom is oldest and at the top is youngest. Here we have a section where younger is at the bottom and older is at the top. How it can be explained? There are three methods out there. See, sediments older and younger. They deposited on the land and they have been eroded and they deposited into the sea. So the younger came at the bottom and older at the top. Is it possible? No. Why? Because these are the marine sediments, 10 to 12,000 year old. And 10 to 12,000 year later part of the presentation, I will tell you about sea level changes. Sea was somewhere here. So when sea was not here, how a marine sediment can get deposited at this spot? So this is not possible. Okay, sea was lower, so the normal sediment deposited into the sea. Second option. And another technical influence, they got folded. Now, older came at the top and younger at the bottom. If you take a core, this type of sequence comes. But whether this is possible? No. 30 centimeter loose sediment for 1,000 years, you cannot fold like this and retain there into the sea for hundreds of years, thousands of years. So this is not possible. Then the third option is when 10,000 years back, sea level was somewhere here and normal sediment deposited. Now, something has been eroding this sediment. See, this is a normal sediment which is getting deposited. Now, sediment eroded and deposited here. Again, normal sediment. And again from here. And if you take a core here, you will get the older sediment at the top and younger sediment at the top, bottom. This is possible? Yes, but it needs a very special explanation. It's a very unusual phenomenon because they are transporting the sediment from deeper water to the shallower water against the gravity. This is possible under either storms condition or tsunami conditions. So this is a concept which need to be tested, and if comes true, and if we can generate the data for our last 2,000 years, the history of tsunami, probably we may develop, like monsoon, may enhance our understanding about the predictive models. Which are the best areas which can be tested is the coastal lakes. See, a normal sediment is getting deposited here, like this. And if a tsunami comes, it cross over and deposit here the marine sediment. Again, the normal sediment is getting deposited. The second tsunami comes. Now, so if you take a sample here, so you will get the sediment, which is a lake sediment, which will mostly divide of foraminifera, and then you will get a transported sediment, which will have a foraminifera. So no forams or less forum, then more forum. No forum, more forum. If we develop it, put the dating, we may get an idea about the past tsunamis. Now, the best area for the students who can take up this as their projects or as a career are the Pulicat Lake and the Chilka Lake. These both are on the east coast, and Bay of Bengal by and large. So if who knows, like monsoon, if tomorrow something develop it will be. Coming to the third of the environment where the foraminifera is the sea level changes. If you want to generate the idea about sea level changes or a sea level curve, you have to follow the two-fold strategy. When sea level was higher, where to get this is see, you have to see on the land. This is a notch, and this is a sea cave. Now, this notch means sea level should be here, but sea is somewhere here. It means when sea level was higher than today, this notch and this cave was these are the erosional features. The material which is eroded from these areas have been deposited somewhere. It is like it is from Goa. When you come from airport, the Chekalim area, you can see the shelly layers. So these shelly layers were formed, and this area was eroded when sea level was higher. You can date this carbonate, and you can tell that when sea level was higher than today. But things are much more difficult when sea level was lower than today. See, this is a slide here along the Indian coast, or here also. This is having a foraminiferal fauna, which is showing the age about 10,000 years, and this is a shallow water fauna. What a shallow water fauna is doing here. Those who are from sedimentology, we get oolites here. Oolites also indicate a shallow water environment. So how the shallow water indicator doing at the sea? At the same time, we have a shoreline movement. See, if sea level go up, what happens? The shoreline keep moving towards the coast. And if sea level is going down, the shoreline goes away from the coast. So these are the indicator of the shoreline movement. This is a foraminifera on which a barnacle is incrusted, and this barnacle is indicating the intertidal environment. And when you date them, it comes about 10,000 years old. Another method by which you can get an idea about past sea level changes is the ratio of planktonic and benthic ratio. It's very simple. Even a high school student can do this. You take a core, and what we have done, we have taken a surface sediment and developed a numerical model. So in this numerical model, P is the percentage of planktonic at a given depth. This is planktonic percentage, and this is a depth. So you put the value of P, and you get a depth. So more planktonic, it means higher the depth, less planktonic, lower the depth. And therefore, you can generate a sea level curve if you just calculate the total planktonic percentage into the given samples in a core. Then you can rate those levels, and you can say that when sea level was higher or lower. So that's what we have done for our region. Another method is you see that this, I told you already, this zone is indicating a shallow water fauna. Something like you can see the bathymetry here, and this fauna is a very shallow. Even Myanmar. This was a work of my PhD student, Dr. Praveen Hanik, who is now there, head of department. And this is a work of Rajni Panchang. Now she is in the Pune University. This is Myanmar. Both the sides you can see this type of pinnacles, and on them the foraminifera, which is indicating the shallow water environment. How it is possible? See, if sea level is here, the depth indicator species are here. If sea level started going up, what will happen? See, the species try to live by through migration and with the rise in sea level. But they are unable to keep the pace in the rise in sea level, they become extinct species. Now, if you date them, this will be the oldest and this will be the youngest. So you know the depth from where you have recovered, and you know the timing. Put time versus depth, you will get a sea level curve. This is what we have generated, a sea level curve. Around 15,000 years back, the sea level was about 100 meters lower than today. See, presently sea level is here. Okay. Now, if just imagine, if you follow the 100-meter bathymetric contour from Bombay, miles together, you have to walk into the sea to reach the beach. 100 meters. After that, sea level started going up. And around 7,000 years back, it has gone above the present sea level. Then again, around 3,500 years back, it became lower than today. Again, around 2,000 years, it has gone up and it has again gone down. Now, we're not a very good resolution for the last 1,000 years. And this is the time framework I asked the student, those who are listening. Now, this is your duty, that please join this group and generate the record to enhance our understanding about sea level changes in last 1,000 years. We know about last 100 to 200 years because we have a tide gauge record and our fiscal oceanographer keep publishing their records. And they keep predicting based on the 100-year tide gauge record. Like tsunami, like monsoon, they are also likely to quite off from the actual prediction. Now, this sea level curve became very useful and handy not only into the sea level record and the vulnerability of the coastal areas. If sea level go up, which are the low-lying areas get submerged, that's what there is a prediction. If sea level go up, lot of areas will be submerged into the sea and low-lying areas will become into the sea. This is going to be a big problem. Whether it will really happen or whether such is there any parallel in the past environment. When we started looking into the past environment, we ventured into the marine archaeology. Okay, there I'm going in a little reverse way. See, India today brought out a special issue on the world's oldest city, 9,700 year BC, means 9.5 thousand year back old. They found a remnant of an ancient city at 30 to 40 meter water depth. And India today brought out a special issue that we found the world's oldest city. After that, the Outlook magazine brought out another issue, telling it is all hoax. Because people were finding it difficult to explain how a city can be at 30 to 40 meter water depth. Now, if you see this came into the 2000 and first record of the sea level we published in 1995. Then we modified in 2012. Now again, we are going to update it. Now you see here, 9.5 thousand year back, it was about 20 to 30 meter water depth. Means rivers were joining the sea here, and it is possible to have a city here because sea level was rising at a very low speed. And when it has gone with a much higher speed, this became a submerged city. But so this is the latest finding which we explain, and we republish as by the request from Dr. Harsh Gupta that how the sea level curve explained. And this has solved a big controversy. Whether it was the oldest city, we must be very proud that world's oldest urban settlement we find within our territory, that to submerge into the sea. This is a very proud moment for us. And the city work was done by National Institute of Ocean Technology, and this explanation was offered by us by publishing a second series of paper into 2002. Now, how this sea level curve helped into the marine archaeology is a place called Lothal. See, archaeology in India started with Mohenjo-daro and Harappa. After partition, we lost both to the Pakistan. And after that, there were efforts by Indian archaeologists to discover some of the Harappan settlements, and they came into the Lothal. Lothal means mound of dead. In 1954, this area was excavated by Dr. S.R. Rao, who later excavated Dwarika also. So at Lothal, he found a remnant of an ancient city. When he started excavating, he found the acropolis, houses, drainage systems, cemeteries, warehouse, so many things of a city, but a very strange and very peculiar tank-like body. Big, huge tank-like body. And according to him, this was a dockyard. You can see here, he gave a picturesque artistic view that this is a dockyard. You can see the boats here. He was supported by Lashnik and Fair Service. But in science, nothing goes without controversy. Professor Sankalia, supported by Martin Wheeler, many other archaeologists, British archaeologists, Indian archaeologists, they say, no, it is a freshwater irrigation tank. And there were many arguments, and for about 40, 50 years, they keep arguing. There are a number of conferences, papers, seminars. and it is called Dockyard versus Irrigation Tank Controversy of Marine Archaeology. And marine archaeology actually started from this. See how they were interpreting. They found a few stones with the hole. If you come to an eye, we can show you this. Now, archaeologists by SRO group believe that this is an anchor stone. And since anchor stone, they found it for boat were there, and therefore it was a dock. Same stones used by the other group. They say it is a counterweight to lift the water for the irrigation. Now, objective is same. Interpretations are quite opposite to each other. Dockyard versus irrigation tank. Can you solve this problem? When I visited PRL way back in 1983-84, when Dr. D.P. Agarwal organized a paleoclimatic reconstruction of 4 million years, they took us to the site. And first time I came to know about this controversy. I thought, why this controversy is on for so many years? It should be very easy for us. What I did, I just collected few samples from here. And I came back and I analyzed in my lab, and I found a well-preserved foraminiferal fauna which can be equivalent to the estuarine fauna. Now, presence of foraminifera in the sample from this so-called this tank-like body said that this was filled with the marine water, and nobody irrigate it with the saline water. This has tilted the argument in favor of the dockyard theory. But few questions remain to be answered, which I didn't tell you. See the Lothal today, if you see, about 12 kilometers away from the sea and few meters above the present sea level. So when sea level was not there, the area is so much away from the sea, how this can be a dockyard? This was possible only if sea level was higher than today. Archaeologists tell that this is about 4,500 years back. Now, if you put this timing on sea level curve, you can see 4,500 sea level was higher than today. So this is a proof that yes, it was connected to the sea. It was a dockyard. This is the oldest dockyard ever discovered in the world, which is in our territory, and we must be very proud of it. Others have yet to discover any dockyard in their territory. And sea level curve very well explained based on the foraminifera that we have the oldest dockyard. Now, another very important, and recently we have done it in Dholavira. Dholavira is in Gujarat in a run of Kutch. And this is a very famous World Heritage Site, ancient city which is about 5,000 to 6,000 years back. Dr. Bish got a Padam Shri for excavating this. Now, if you see the site plan, this is called Citadel, or where the VIP areas. This is barely a bureaucratic area. This is a middle town and this is a lower town. Now, this lower town, this entire area has been surrounded by about 6 to 7 meter thick wall. But this castle area has been surrounded by 18-meter thick wall. 18-meter thick wall. Can you imagine? The China wall is not that thick. Even a lot of forts in India, the best one is Kumbhalgarh, which is very near to the Udaipur, and which is the second largest wall, the longest wall in world. There also it is only 15 feet thick. Now this is 18-meter thick wall. Why they have done it? See, I asked them why they 5 to 6,000 years back they have built 18-meter thick wall. They say because for the protection. Yes, protection against whom? Against animal, 1 foot was enough. A bar was enough, bamboo bar. Against the flood, natural calamity like flood. This is water-starved area. Incidentally, Dholavira is world famous for their water conservation system. So in a system where water was to have been conserved, why somebody has to make a 18-meter thick wall to protect it from the flood? So flood cannot be the reason. Then enemy, 5,000 years back when gunpowder was not there, what were the weapon of the enemy? They were fighting with the bows and arrows and the stones. For that, 18-meter thick is not required. So then we gave another explanation. See, Dhalavira is on the Makran coast, which is a tsunami-prone area. And for Subodh Chaturvedy's thesis, we have already reported a tsunami which is 8,000 years back. Already I showed you that work. So it means these people of Dhalavirian, they knew that this is a tsunami-prone area. But this was strategically very important for the trade. Okay. So therefore, they have to build the city. But the most VIP areas, they have to protect it. They have to protect it. Therefore, they built 18-meter thick wall. But whether this wall could protect and whether any other indication of the tsunami, what we did in the lower town area, we have done a GPR surveys. And GPR surveys till about 2.5-meter thick sediment have no layers. See, if sediment deposited naturally either riverside or seaside or beyond, even on the beach, if you go and cut a section, you will get a layer. But if you put a truckload of sand, means one-time deposit, you will not get any layer. So we didn't get a layer. Therefore, we got a permission and we dig a trench and we collected the sample. Now, idea was that this one-time deposit, whether they are river-borne or they are sea-borne. Now, we found a very good population of foraminifera. So therefore, it is a sea-borne sediment. And therefore, it has confirmed that tsunami did hit this area in the lower town area. Now, for the future work, we have to see whether this, so the 7-meter wall could not protect themselves, these people, from the tsunami. So Middletown was destroyed. But whether the citadel area was also affected by tsunami, it means a survey needed into the citadel area. Some of you, those who joined NIO, may do this work tomorrow. So this is Randrabad, and I was looking after the marine archaeology unit also. We did a lot of work on marine archaeology where the sea level curve has explained very well. This is a Neolithic settlement, I told you, of Surat area, which was done by, this is 30 to 40 meter water depth. Then Ram Setu also can be explained by the sea level curve, which is basically generated based on the foraminifera. Then we get the Lothal and then Dhalavira. When sea level was higher, the cities were built up. Then we get the Lothal, when we get the Dwarka. When sea level has gone down, Dwarka was built up. And when again sea level has gone up, this became a submerged city. And then we get about Kumbha and the Bed Dwarka signature here. And recently we are doing it Gopika Patnam, which is in this area. So with the help of foraminifera, we generated a sea level curve. And with the help of sea level curve, we could enhance our understanding about the marine archaeology, what happened in the last 5,000 to 6,000 years along the Indian coast. And here is a message for us that if you come and occupy cities very closer to the sea in low-lying areas, and if the sea level go up, you may end up something like a Dwarka-like situation. Once I talk on the marine archaeology, many times people ask me why someone has to be interested in the past environment or why someone has to be interested in a cultural heritage. Two reasons. First, the one who is proud of his or her cultural heritage always work hard to maintain the high level of civilization and thrive to enhance the living standard of the fellow citizen. And not only that, this marine archaeology things are likely to enhance our earning through the tourism. So we have a oldest record of the cultural heritage in form of the Lothal within our boundary. You go to Europe, which is earning a lot of money through the tourism. They have most of the things within 2,000 year old. But here we have a 4,000 year old, we have a 6,000 year old, we have the world's oldest evidence on land about the tsunami protection, 5,000 year Indian wells have a that is within our bound. Therefore, there's a lot of more research is required, and I'm sure foraminifera, paleontologists, or geologists are going to play a very important role. I extend a good luck to the future workers, the present day student. Thank you very much. These are the students whose work, 16 students of our lab. This is our paleontology lab. We have the world-class foraminifera culture lab at NIO, which is the only lab in Southeast Asia culturing forums. Thank you very much. This is a small step to unravel the past in order to illuminate the future. Thank you very much.
Thank you, sir. It was really a wonderful talk, and it opened up so many avenues to the to the micropaleontological community to start doing research in the field of marine archaeology, which is still a very new aspect of this field. So it was really wonderful to listen to your talk, and I'm sure that our students will be benefited with your talk for their postgraduate exams and entrance exams as well, because most of the thing which you told was already in the syllabus as well. So I would like to request our organizing team member, Mr. Akil Kumar Dwivedi, to kindly put a few questions in front of speakers. Akilji?
So you are going to have question answer session now. Very good. I will love to answer any question.
So we are just trying to ask 2 or 3 questions regarding your talk.
Sure.
In live
You
chat,
can
there
ask
is
the question on the thing which I have not presented also, like pollution studies or fisheries, like that also.
okay. So first, as Mr. Akhil Dwivedi is not able to communicate right now, I would like to ask our all faculty members who are here on this platform to ask any queries to our speaker.
Sir, I would like to ask that uh, for the sake of young students of graduate classes, you may
Yes.
please explain what we actually mean by proxy and uses of proxy as such in geology in general.
See, proxy, what we say that I told you why we, first thing, why have to reconstruct the climate. So I told you, see, through reconstruction, see, geology is based on the principle present is key to the past. So, based on the present study, we extend it to the past and we reconstruct the past. Now, past and present, when we put together, we get an idea about the future and we can do the planning for our survival and benefits. Now, how to do past? None of us has seen it. So we use the proxy. See, for example, temperature is the parameter. What we used to actually want to know whether temperature has changed in the past or not, whether salinity has changed in the past or not, whether sea level has gone up, but we don't have any direct method to measure them. So we see that how they affect the parameter which became fossilized. So any organisms which live today, from where you can develop the model, develop the proxy, and then you apply it to the sediment deposited during last thousands and millions of years, and then you can say that when they used to live, this was the environment, and then we can generate entire record. So this is called the proxy records. Since life is always get affected more in the see, for example, in your room you start enhancing the temperature. What will happen? The people from hill area, means those who are more sensitive to the temperature, they will go try to go out first. They, then the other people, then almost everybody. If they cannot go out of, if they cannot migrate, they will die. Then furniture, then this rock. So the sediment is the last one to get affected. Therefore, fossil always are the better uh, tool for reconstruction of the past climate through the proxies. So I say foraminifera as a proxy for climatic change. And then, like these days, we are using them for uh, pollution studies. We are not measuring the say, arsenic or mercury into the environment. I am measuring the forum and telling that this factory is polluting. So it is a proxy for pollution. It's a proxy for the fisheries. When we are able to tell about migration of the fishes by studying the foraminifera. So foraminifera is a proxy for the sea level, foraminifera as a proxy for monsoon, foraminifera as a proxy for tsunami. So this is called the proxy for the climatic reconstruction.
Thank you very much, sir, for giving us the elaborate answer for what we call a proxy. That will be very beneficial for our undergraduate students. There is one question from one of our PG students. He's
Okay.
asking, "Sir, I want to join this work at NIO. What is the procedure to do this?"
I'm very happy at least one person got interested to come to NIO. So good. Uh, see, there are many methods to enter into NIO. Okay, it starts uh, with the uh, summer training or winter training. You can come to our site nio.org. You can see what are the work going on, and then you can come and join. And if you come through uh, the INSA or the science academies, all three academies now sponsoring some of the students. So you can come and work with us while being a BSc or MSc student. I'll tell you a very interesting example. Priyanka Banerjee, she came to my lab, worked with me when she passed intermediate as a youth promotion scheme program. She worked for about 1.5 months. And she worked on Mandovi estuary as her report. And that report we published into the Coastal Research, Journal of Coastal Research. And when she did BSc from Jadavpur University and MSc from Roorkee University. And when she wrote me a letter afterwards. When Dr. S.S. Shrivastava started teaching her the foraminifera as an indicator of pollution, this lady got up and said, "Sir, you are teaching me from my own paper." He said, "Dr. Nigam's paper. You see, the second author is me." So see that she was taught by her own paper, and that she said that is a proud moment for me. So you can come as a summer trainee or winter trainee. Then you can come as a project trainee. We keep advertising the project trainee positions. So as long as the project is there, you can work as a MSc student or as a BSc student, project trainee 1 or project trainee 2. After MSc, if you qualify the NET exam, then you can join as a research scholar. Either you can join as a ACSIR, because they also now give degree, or we register our students in different universities. Before we started this lecture, we were discussing about PRL people there. And now people are submitting their thesis into Goa University, different department, depending upon their specialization. Pune University, Andhra University, and Mangalore University. So as a research. So depending upon your choice, but I will suggest you, when you are doing your MSc, please appear for NET exam. It's not very difficult exam. And once you qualify that exam, you become a chooser. You can choose your institute, you can choose your guide, and you can choose your subject. So this is the way you can enter into NIO.
Thank you, sir. Sir, there is one more question from one of our undergraduate student. He's
Sure.
asking why Lothal isn't still included in the world's wonder.
See, we are very shy, or uh, this is a lack in the planning. See, if foreigner comes to India, or you ask any foreigner, if you're coming to India, what you would like to see? They will say Taj Mahal, Lal Killa, Qutub Minar. All these things are been built in last 300 to 400 years. Just 300 to 400 years. Okay, because a lot of importance has been given to only these buildings. As in India, cultural heritage means Taj Mahal, Lal Killa, or Qutub Minar. India is a 6,000-year-old thriving culture, and still lot of, see, before on 100 rupees note, Rani Chi Vav, means the step well of Queen in Gujarat came. How many of us were knowing about this wonderful building in Gujarat? And before this lecture, I am telling you, just question yourself, how many of you were knowing about Lothal? How many of you were knowing about Dholavira? And how many I have not talked today? Otherwise, Mahabalipuram, Ram Setu, Pumphar, Gopika Patnam, this 5,000 world's oldest evidence of tsunami protection is in within our country. If we project it properly, popularize it, nowhere else in this world this thing is there. Recently, Japan has made a 11-meter thick wall to protect themselves from the sun. Lothal, such a wonderful. Rakhi Gadi, just near to Delhi, is bigger than the Harappan or Mohenjo-daro. Samkalin जिसको बोलते हैं. Equivalent civilization. How many of you know Rakhi Gadi? Dr. Shinde now from Deccan College, he is working on that DNA studies. So friends, it is our duty to tell about our cultural aspects. And problem is, we are not sure about our cultural heritage. Like Lothal, people were very shy for 40 years. We are not sure what we should tell others, dockyard or irrigation tank. See why this problem was there for 40 years? Because it was discovered in 54 and we published the paper in 88. Okay, more than 40 years. Why? Because archaeologists were arguing with the archaeologist. So there is a need to interdisciplinary research investigations. Moment as a paleontologist, it was 2 days job only for me to tell that it was a docket. And now it is settled. And now the government of India is making a very good maritime heritage museum at Lothal. At about more than 100-acre land, Dr. Shinde is the Director General. The office is in Gandhinagar. I think within 2-3 years, you will get. Now the Lothal is getting its importance because now the government policies has changed to give importance to our cultural heritage. And I can assure you, the student, no question is a bad question. Only thing, I may be knowing the answer or might not be knowing the answer. So don't be shy of asking the questions.
Thank you, sir. Thanks a lot for your such a wonderful spirit. Also, as there are faculties from other departments like botany
Sure.
departments, they are here and they are really praising your talk and saying it's a beautiful and knowledgeable webinar. Thank you, Rajiv sir, and all the speakers. So, sir, right now we will stop here for your talk and we will start with MD Yadav sir.
Okay, just few seconds I will take.
Okay,
I
sir.
must thank the Vice Chancellor and the organizing committee, Ankush, you people, for giving me an opportunity. And I really love to talk to the students. So anytime if you want, I'm always available for you or anybody else to talk to the students. I really enjoyed the talk with you people. Thank you very much.
Thank you,
Go
sir.
ahead, please.
Thank you, sir.
And welcome, Dr. Yadav.
We will definitely organize another talk for this, and especially on the marine archaeology, so that we will enhance the awareness among our students. Thank you, sir.
Sure. Most welcome.
Yadav sir.
Yeah. Yes.
Nigam sir, you can stop your share,
Okay.
screen share.
Okay.
Yes, sir. It's okay.
Now,
It is stopped.
Yes,
yeah,
sir.
it is stopped. Now, okay. I should press the
Yes.
present now.
Yes, sir. Present
Present
now
now.
and then present entire screen.
Your entire screen.
Then click on the window and click share.
Entire screen. Yeah, yeah. Okay. It is coming.
Yes, sir. It is coming.
It is coming.
Yes,
Okay.
sir. So I'll welcome Professor M.G. Yadav sir, Geoscience Division from Physical Research Laboratory, Ahmedabad. He'll be talking on the paleoclimate from cave deposit that is called, we call speleothems here. I welcome you, Professor M.G. M.S. Yadav. Sir, you can start now.
Yeah. Okay. Thank you. Well, let me first thank the dignitaries of the university, and I thank Dr. Ritesh Purohit for kindly introducing me. I also thank Dr. Ankush Shrivastava for inviting me here, and the team members. The team members, Dr. Anjali Singh, Mr. Akhil K. Divedi, and Mr. Niranjan Mohanty for being part of this webinar. And good afternoon to all participants. See, after the previous very clear and crisp presentation on how the foraminifera can be used to address the paleoclimate, paleo environment by Dr. Rajiv Begum, who is eminent authority in this discipline. Now, I would like to be very specific. I would be presenting how to extract past climate information using cave deposits. So when I say cave deposits, that means the speleothem, they are calcium carbonate deposits. So what you will be listening now, I will start with some information now, general information on caves, the origin of caves, and then the formations, speleothem formations, then the basis of paleoclimate reconstruction, some dating methods, the kind of the techniques which are used, and then I will give some flavor on the Indian studies. So just this is a general slide that to begin with, that you know that there are different archives. See the past climate, the information on past climate. You know that instrumental records, the temperature, humidity, rainfall, all these things are available for limited period of time, that maybe 50 years or 100 years or so for big cities. But then if you want to extract information, back in time, then you have to go for archives, natural archives. This, you know that tree rings are there, they have highest resolution. Then you have a coral. So the tree rings will give you information, environmental information, the terrestrial information. The corals can be used to address the sea surface temperature variability, the salinity, all the surface, shallow surface information can be retrieved with very high resolution. So the ocean pores, you know that the marine and lake sediments, they can be used, the foraminifera, previous in the presentation you had understanding on that aspect. So even lake sediments, then comes the cave samples, cave deposits. Now as such, these are the archives, and the prime information which we want to retrieve back is the if it is possible, then would like to know what was the past temperature, what was the past monsoon condition, all these things. That too, not qualitative. Would like to, our interest is to have a quantitative information. But as you will see the slides, it requires several considerations. So the the kind of the isotope ratios and then geochemical parameters where the past climate change they are recorded, they are all the proxies. Okay, so isotope ratios and then the geochemical parameters, let's say concentration of trace elements or major elements, even physical properties, the concentration of foraminifera, all these things, they are the proxies. So the proxies are actually they are the preserved physical characteristics of the past that stand in for direct measurement. The direct measurement is that means the isotope ratio can be measured, the trace element concentrations can be measured. So they are said as a proxy, and these are the archives. Now, for all these archives, they have specific mechanisms, the basics of basic concepts, the basis of reconstruction is entirely different. And then there are limitations as well as advantage and disadvantage. For example, tree rings, they have very high resolution. They can retrieve information at annual scale. Then corals, they can also retrieve information at annual scale. But at the same time, the corals have additional advantage that you can go for sub-seasonal seasonal scale. So that way it has some advantage. But the disadvantage is that the temporal coverage, that means if you want to go back in the time, it is very much limited. The tree rings, the corals, you cannot go back much in time. And ocean cores, it can go back in time. It can cover several thousand or a million years, several hundred kilo years of that scale. But the issues that there are perturbations, there are averaging effect, and the only slow changes in the Earth's climate can be retrieved from ocean core. And the lake sediments, they suffer a lot because of several processes which occur on the land surface, and then the archive is usually destroyed. So the preservation of the signal or retrieval of the signal becomes very difficult. Cave deposit is a unique system, and then it is very unique archive. Why? See, because the caves are well protected. There is a bedrock and the soil zone above that. So deposits occurring inside the cave that are called by skeletons, they have a very good potential to address the past terrestrial the climate change. Now, again, the isotopes and then the geochemical the parameters, they are used to extract the information. Here, I would like to give you some information how the origin, what is the way through which the caves are developed. Dr. Shrivastava, am I audible?
Yes, sir.
Hello?
Yes, sir.
Yes, sir, you're audible.
Yes,
Oh,
yes.
okay, fine.
Yes, sir, you are audible.
Okay,
Very
okay, fine.
clear, no problem.
Okay, thank you. So, see, when we talk about the caves, then for climate reconstruction, we talk about the carbonate kind of the structure. So that means the limestone, the calcium carbonate type of skeletons are usually used for addressing the past climate. Now, see how these caves are formed. So let me explain you here. See, usually it's a limestone terrain. If there is a drainage valley, if my cursor is seen here, the drainage valley is shown here, and due to the rain, so the water will flow from here, and slowly it will be eroded. Physically, it will be eroded. Maybe partly, even chemically, also it will be eroded. So, in due course of time, the size of the drainage valley is it increases. It goes further down. So now what happens that there are fractures. I mean, there may be fissures also. So inside these the passages, the water, rainwater will be trapped, and the rainwater as such, you know that through interactions it physically remove the material and also chemically, because mild carbonic acid may be there. So in due course of time, what happens that the fractures, they are widened up. For example, in this photograph, you see that slowly the water goes from the top, and then the duct is widened, and this is how it is beginning of the formation of the cave. In as the time passes, after maybe several kilo year or hundreds of kilo year, depending upon the kind of the weathering processes. So the cave becomes large, and that is what you see here. And this process continues, and then finally you see that large caverns are formed. So this is the beginning of the formation of a cave. I want to tell you one thing, that this is because this is a continuous process. So eventually everything will be removed. So you will see that after some time, and there are places in Andhra Pradesh, there are some locations where you can see that the whole structure, the roof has gone on the floor, because everything will collapse in due course of time. If things are removed, then because of the overload, the roof will fall, and then finally it will be destroyed. So this is the first photograph shows the birth of the limestone cave, and then finally it enters like this one. Now, of course, such caves should be observed in the locations where there are a lot of limestone rich area. So, for example, this is the limestone outcrop the world, and several big caves, huge caves are reported from the European and then American countries. We have a limited limestone, the belt available, and there are locations where some known caves are there. And I want to tell that the for formation of a cave, maybe there are underlying limestone caves, but we are not much aware, because our limestone is basically it is documented for mineral exploration and for commercial purposes. So as such, we don't have the adventurous group of people, because in Europe and then other countries there are groups who are willingly going for the adventure kind of activity. They explore these caves, and then it comes out in the public notice. So in India, some caves are known, but then I understand, and then I believe formally that there may be several other unknown caves. So this is a picture photograph. It shows the entrance of the cave. When you start going inside, of course, it will be dark further. And when you enter inside, so it becomes totally dark. And as noted here, cave is very hostile. It is written merciless and a strange environment. You might have gone through some news report a year back. And it is totally dark. And if it is not well documented, then it may be very dangerous. There may be vertical shaft scenes may be there, and it may be full of water. And even the rescue becomes difficult. The rescue can be carried out, rescue operations are carried out only by the trained the people. Now, here is a photograph. It is a beautiful stalactite. It is beautiful stalactite. So these are the deposits, calcium carbonate deposits. And this photograph is from Dandak Cave. You may see the irregular structure. See, the irregular structure is all because of with time, the drip position from the roof keeps changing, and then the irregular structures, although they add to the beauty of the cave, so irregular structures of formations, they provide different kind of variety of deposits. So, for example, this one is it is also having some color. Now, the color is all because of the trapped the chemicals which has come from the overlying bedrock zone. Now, here it is just to give you idea that when you enter a cave, then you may see a deposit or something like this one, where somebody is standing here, huge deposit. This is a kind of a pillar. Eventually, it is going to meet the top deposit, and then again some irregular but beautiful shown samples are shown. The samples which grow on the floor and typically of the size of a feet or maybe close to that, they are the valuable piece of the kind of deposit which gives interest to paleoclimates. So why? There are the practical reasons, because they look to be very straightforward, vertical, exactly vertical, and then it becomes very easy to connect them also, because in most of the cases the cave entrance is very narrow. It is hardly 1 or 2% can enter through the cave entrance. So the entrance is very narrow, so you cannot bring out huge samples. So the sample size is all limited. So practically, these are the samples which are explored for extracting paleoclimate information. Now I come to this slide where I want to spend some time to explain you why and how these deposits are formed. So it is a schematic diagram which tells how the uh, cave system, in general, the cave system will have a overlying bedrock, and because it is a limestone rich area, so and then there are fissures, there are breaks in the formation. So the top surface is having soil. Good vegetation is another part, and so because of good vegetation, obviously there will be respired CO2. So this soil CO2 is very high. Usually it's very high, and the CO2 partial pressure is usually 10 to 100 times more than whatever is occurring in the ambient air above the cave area. Now, there is another component that means which adds to the high PCO2. It is because of the biological process. There are microbes, there are biological activity which decomposes the organic material. So respiration and then decomposition both contribute to high PCO2 environment. And because of this reason, the zone which is below the bedrock and the soil is rich in the PCO2. And this CO2, because the gases are having a high partial pressure of carbon dioxide, so they will enter into the water. The water source of water is the rain. So the rainwater is the prime source of water in the cave. And the CO2 is coming from the because of the decomposition and respiration. Both add to the acidic environment, and finally the carbonate, the mild carbonic acid is formed. So H2O plus CO2, you'll see that the bicarbonate, it is the carbonic acid, H2CO3, it is formed. So that means the water is becoming mild acidic. This water will leach the calcium carbonate, and finally the water, whatever is below the bedrock zone, it will be laden with the calcium and then bicarbonate ions. Now here in this zone only, whatever constituents in the bedrock zone are there. For example, the trace elements are there. There may be uranium, there may be thorium, there may be magnesium, strontium, barium, or all chemical constituents of the parent bedrock. That will also come in some way, and they will be part of the water. So the seepage water. Now it is seepage water. Now, once the seepage water, it finds some way en route, and then it enters the cave gallery. The cave gallery, which was formed because of the water in geological time scale, or maybe in a long time scale. Now, the cave gallery, as such, it is open to atmosphere. Since it is open to atmosphere, so that means the air circulation will be there. Of course, the air circulation in these kind of caves, they are very poor, but still there is a circulation, and because of the air circulation, the partial pressure of carbon dioxide inside the cave gallery is it is less than the bedrock or the below zone, the seepage water. So what happens that it finds that there is from high pressure, high partial pressure, it is exposed to low partial pressure environment. So the reaction goes back. That means the calcium and then carbonate ions, they recombine back and then start forming the calcium carbonate. So in due course of time, they start depositing back the calcium carbonate, which was retrieved from the overlying zone. So this is how the formations stop. They started preparing, and this is called the stalactite. The samples which grow on the roof of the cave, they are called stalactites, and the water, it will continuously drip on the floor also. So remaining carbonate will be deposited on the floor, and then they are called stalagmites. Now, what I want to tell that stalagmites are very interesting because the internal structures are quite straightforward, whereas stalactites are not preferred for paleoclimate reconstruction. So now going to further, when the stalagmites are cut across the growth line, then you see that there are beautiful sections. In some of the cases, these pieces, they have annual laminations. For example, this one, the distinct layers are there. So it is equivalent to kind of a tree. And in between there are some trapped particles, dust particles, organic particle may be there. And so they, in some way, one should try to extract them, and using some analytical method, some information about the past can be obtained. But established method is to, because this is calcium carbonate, so established method is to process the calcium carbonate. For example, here dots are seen. So it is samples have been taken for stable isotope measurement, and then for some chemistry. But in other cases, for example, these samples, the laminations are not annual, but they may be decadal or more. We don't know unless scientifically some ages are certain. If they are assigned to these deposits, it is not possible to tell whether they are annual or decadal. For example, here in this particular sample, some portion is very clearly banded, and it seems that they are annual in nature. But then afterwards, the bandings are missing, and even colors are not. They are not transparent. They become dirty. So something happens. Even based on the analysis of stable isotope, it could be possible to say. But otherwise, also from the physical properties of these deposits, one can extract some information about the past. So this is a typical structure of the stalagmites. The growth starts from here, it goes this way because the base part is the floor, and it is growing towards the roof part. So the growth is going towards, this is the growth axis. In several of the samples, there are breaks also, and the breaks can be identified if there are dirt particles, the dust particles, detritus particles are trapped, or the color is changed, or some whites are there. Physically, there will be a distinct feature which can be used to say that there is a growth or break in the formation. But in order to authenticate, one needs ages. That means you find out age here and then find out age here. If there is discontinuity, you can establish that, of course, there was a growth in, there was hiatus in the growth of the speleothem. And if they are distinct, then you can count them. You can count them and then assign ages to each layer. But if they are not distinct, then the methods which are used is the radiocarbon, the 14C dating method, and then the uranium thorium dating method. Now the radiocarbon dating method, it has some uncertainty because if you recall this part, I would go back again to this part, because the carbon whatever comes here, see in this equation we'll see that the calcium and the carbon is coming from the bicarbonate, and then the bicarbonate ion, it receives carbon from the soil CO2, which is modern. It is having modern radiocarbon activity, and then one more carbon comes from the limestone bedrock. So that means both will contribute to the radiocarbon activity of this formation. So it is a little tricky. It is not straightforward because there are the deposit post dissolution processes are also there. For example, the residence time of this water, and then how long it is in touch with the carbon dioxide. So all the gas and other things are there. So a little complex, but eventually what happens that there are some variability, and variability in the dead carbon that limits its utility, but for sure it can be used to give tentative ages to these kind of deposits. Uranium thorium method is a pretty straightforward and very well established method currently being adopted everywhere. But in certain cases, even it has some limitation. So what I would like to make a comment here is that there are cases when this method fails, but there are cases where this method also fails. So in such cases, one has to use both. I mean, it should be complemented. So both methods they give very good information as far as the cause is concerned. It may so happen that one ends up with some kind of situation where even radiocarbon fails, and then uranium thorium is also failing. So there are such situations. Now, I just want to tell you that the same thing is highlighted here, the calcium carbonate on the stalagmite surface. You see that the carbon comes from soil CO2 and then the bedrock. The soil CO2 is having 100% radiocarbon activity. The bedrock is just dead. It has no radiocarbon. If you are familiar with the concept of radiocarbon dating, then see the activity of, if you measure the radiocarbon activity here, then you can assign age to this particular lamination. So the proportion of these two, it keeps changing, and that is the kind of limiting factor, and that is why I say that dead carbon variability adds to age uncertainty, but still it gives some age information. 230 thorium and 230 thorium uranium disequilibrium dating method is the established method which is currently used. Now, the basis of use of this method is like this, that you know that there is secular equilibrium in the rocks which are very old, the bedrock like the limestone bedrock. So it has gone through geological time scale, and then that means it has a secular equilibrium. Secular equilibrium in the radioactivity, that means its activity, 238 uranium activity, then 234 uranium, all daughter and parent elements, they have same radioactivity. That is what is called the secular activity. And that means this condition is fulfilled. And but the moment there is a dissolution, so in the bedrock there is uranium and thorium, and the thorium, chemically it has some property that it remains attached to the detritus constituents, whereas the uranium goes in the solution, that means the seepage water. So in turn, what happens that in ideal situation, the water which is dripping and then forming a stalagmite, it should have only uranium. As such, it should have, in the ideal case, should have only uranium. There are cases when the calcium carbonate is formed and then some detritus content also goes inside the calcium carbonate matrix. So that means the thorium also goes. So it creates a problem as far as analytical methods are concerned. And see, the trapped detritus contributes to the age uncertainty. What is shown here that once in this particular curve, once the seepage water drifts on the freshly growing stalagmite surface, so the ratio is 0 because now only thorium is there. Only no thorium is there. Only uranium is there. So ratio will be 0. 230 thorium, 230 uranium. So ratio will be 0. But as the time passes, because it has to go through the secular equilibrium kind of concept, so again the ratio starts built up, and then eventually it will lead to constant value 1.0. So this time it tells you the age of the stalagmite formation or the age of the particular lamination. The machines are there, very good instruments are there. Nowadays, advanced methods are used like multi-collector ICT-MS. So one can measure these ratios, and there are methods to finally estimate age by the uranium thorium dating approach. But again, if there are detritus materials, then it will lead to a lot of age uncertainty. And see, there are samples. It is so-called. It is labeled as a dirty samples, spilitones, dirty spilitones, where the lot of detritus contents are there, and they are a challenge to actually paleoclimatologists to how to deal with them, how to assign chronology to them, and how to extract meaningful paleoclimate information. Now, coming to the proxies which are used. So the proxies which are used, see, we want, our aim is to get straight away. We want to know what was the past temperature, what was the rainfall amount, all these things we want, like the instrument, like thermometer or the rain gauge systems. But then the nature doesn't allow you in a simple manner. So there are elements which have isotopes, stable isotopes. For example, hydrogen, carbon, and oxygen. So these isotope ratios, they are having very well defined value in major reservoirs, like the atmosphere, let us say the huge ocean, river, all these places. If the reservoir size is very large, then they will have a specific ratio. But once they pass through some kind of a physical or a chemical processes like formation of spilotherm, evaporation, condensation, all these things, then the ratio changes. So the ratio change can be used to address these kind of the processes, including the physical, the chemical, even the climate or environmental kind of the signatures can be retrieved by using these ratios. So, for example, for spilotherms, it is the carbon and oxygen, because you know that the spilotherm is a calcium carbonate. So that means mainly it is calcium carbonate, almost 100%. Whatever contaminants are there, they are at very low level. So carbon, that means carbon isotopes can be used, 12C, 13C, and then 14C can be used for dating. And oxygen, you can use the oxygen isotope ratio. So carbon and oxygen isotope ratios are used as a proxy to retrieve the past climate information. Okay, and now while doing all these things, you also need information on the isotope ratio of oxygen and hydrogen, because water is there, K water is there, and it is H2O. The water has come from the rainfall, the ambient rainfall, local rainfall. The oxygen is eventually affecting the oxygen of the spilotherm. The hydrogen is of course not, it is related some anyway with the stalagmite material, but then the hydrogen and oxygen together, they are having some information about the local meteorology. Now, for your information, the isotope ratios in this kind of exercise, the climate work, paleoclimate work, you will often see that they are denoted in terms of delta. The delta is a ratio of sample divided by standard. Then you have to take a difference from 1 and then multiply by 1000. Now, what happens that I told you that the ratios, they change when there is a physical or chemical processes, or there is a climate driven or environment driven processes are there. So the ratio of the isotopes, like if I go back to this slide, ratio of these isotopes, they change to only small magnitude. So the changes are extremely small. So the ratio will change because of these underlying processes, but they will change to very small level. And because the changes are very small, so you need to multiply by 1000. Why? Because you want to find out those small changes. It should be meaningful. When we are dealing with the number, it should be meaningful. It should not be in fraction. So because of practical reasons, it is multiplied by 1,000, and that is why it is called per mil. So you will see that in the climate, past climate reconstruction, often the delta notation is used, and that is per mil. That means per 1,000, and this is the explanation and definition of the delta notation. Now, the stalagmites are basically the not all stalagmites or not all speleothems are useful for phytoclimate reconstruction. The reason I would like to convey here, what is the basic reason? See, in isotope systematics, the process should be slow enough. I mean, when I say that when there is evaporation or condensation or there is physical or chemical process, then the isotope ratio changes by a defined value. But when if it has to be achieved to a defined level, then this process should be very slow. If the process is occurring very slow, then it is called equilibrium kind of process. So it is called isotopic equilibrium. So isotopic equilibrium is achieved. That means the isotope ratio for a system to start with, and then isotope ratio for a system and the system. It will be very well related if the process has gone very slowly, and that is what is the meaning of the equilibrium process. And let me give further clarification. Like this iron it breaks. There is content. You know that you must have gone through the basic chemistry. The concept is that there is equilibrium. So the bicarbonate ion it keeps breaking in carbonate ion. So there is continuous exchange process. If you take a fresh bicarbonate ion and then leave them, then there will not be equilibrium. But then if you keep for some extended period of time, then there will be continuous exchange, and then equilibrium constant is well defined. So this is equilibrium kind of situation. And in only such situation, the isotope ratio on this part and on the other part, they are very well related, and they are related with some kind of a thing like alpha notation is used. Now, when the formations are occurring, the temperature affects a lot. And the temperature relationship, they are empirically related with this one. This is made available by laboratory experiment. So this is very precisely known from laboratory experiment. But then in nature, it may behave differently because of the complex situation. So in nutshell, in order to achieve equilibrium kind of situation, you need to have speleothems growing in a highly humid environment. Why? Because if you go in the interior of the cave, if you see this this equation, the calcium carbonate is precipitated by recombination of these two ions, but it may happen if the carbon dioxide goes, because the cave environment is having good air circulation, or even the water also evaporates. If water evaporates on the cave entrance, then also the calcium carbonate can precipitate. But then it is not good, because it will not lead to, it will be very fast process. So equilibrium will not be maintained. So in nutshell, the statement is clearly given here that you have to collect the sample from a very highly humid environment, suffocated environment. So that means this kind of work is challenging. You have to be very courageous to enter in a very suffocated environment, and where there is a poor air circulation and humidity is very high, extremely high. Now, by giving you some introduction on the stable isotope part, I want to tell you that speleothems, which are collected from caves from mid and high latitude areas, they are used to address the past temperature variation of the those locations. If you recall that I showed you the word limestone outcrop, so that means the limestone areas and the caves which occur in the mid latitude or high latitude zones, those samples, speleothem samples, can be used to address past temperature variability of those locations. Now, why? Because in the modern situation, the rainfall delta T0 and the surface temperature, they are having very linear kind of relationship, and the linear relationship gives you some kind of the change in the delta T0 value, which is 0.6 per mil per degree centigrade. So this is because the local rain is behaving like that. It is responding to the surface temperature. So because of this reason, the same kind of response should be given by the spectrum when we are using delta 18 as a proxy. So the carbonate, when it is formed, I told you that the empirical relations are there. So during precipitation also, there is some kind of fractionation. So actually the site dependent fractionation and then the temperature dependent fractionation both work together, they cancel, and then finally there is finite temperature dependent relationship. So that means whenever temperature rises there, it will add to 0.36 per mil to delta 18 value in the delta 18 of the speleothem. When we come to the tropical locations, then it is entirely different. The situation is entirely different. Why? Because the rainfall here is not showing any kind of temperature dependence, surface temperature dependence. Here the situation is showing relationship with the amount of rainfall. That means in our location, in caves which are from India, the speleothem deposits can be used to address the variability in the amount of precipitation, or we can use to tell the strength of the monsoon, variability in the strength of the monsoon during past period. So why? Because in the modern time, International Atomic Energy Agency has collected rainwater for decades or several decades, and then they found that, see, the average monthly rainfall and then mean monthly delta 18 value, they are having very clear amount dependent relationship. If you recall, in the previous case, it was temperature dependent relationship. Now here it is the amount dependent relationship. Because of this process, what happens that if there is more rain, then the delta 18 value of the rain decreases by minus 1.5 per mil. This is the in general value, average value over a large scale, but one should verify at the regional scale. That I will tell later. So the amount is just to give you some clear idea. See, when the rain is scanty, so the heavy isotopes, they fall faster. That is what is shown by the orange dots here. And some light isotopes also, they condense, they go in the precipitation water phase. But if the rainwater increases, so what happens that the even light isotopes, they also get condensed. And this kind of broad explanation it gives a physical process. It is idea why there is amount effect in these kind of locations. Now, the work requires not only sampling of the cave deposits, but also you need to monitor the rainwater, the isotopic characteristic of rainwater. You need to establish that there is a relationship. The temperature dependent relationship is not there. It is the amount dependent relationship. That means amount effect is really significantly appearing in the sampling area. And then also you need to find out what is the isotopic characteristic of the drip water, because unless you know the variability of the drip water and the rainwater, you cannot interpret the delta 18 value of the calcium carbonate or the stalagmite. So there are the analytical methods. You need to have very precise computer control, precise extraction of samples. Why you want to address as high resolution as much as possible? Why computer control? Because computer control extraction will give you very precision milling. So at micro level you can extract powder samples, and then you know that there are mass spectrometers, such kind of instruments. The mass spectrometers are used to measure the isotope ratio. These are isotope ratio mass spectrometers. So the sample is processed, and finally the isotope ratio of oxygen, hydrogen, or carbon are measured. In addition, you need to process the sample. You know that in small samples can be processed, and it should not be contaminated, because eventually you need to find out the natural variability. So vacuum preparation line, specifically designed vacuum preparation lines are used to process these kind of samples. And I want to tell you that PRL has the recently established accelerator mass spectrometer method, where a small milligram level of calcium carbonate powder can be processed after passing through all these analytical steps. One can measure the age of the stalagmites. Now here I come to one example from the peninsular India. This is near Karwar. One sample, it showed annual laminations, and annual laminations delta 18 on this side is measured. And what we found that with the available meteorological data, we found that all the negative values, they are related with the excess rainfall years, and positive values, they are related with the drought years from the meteorological data. So that means this back in time, whatever information, DR, drought years, excess rainfall years, this is reconstructed. Now the interesting thing is that it is reconstructed very high resolution at annual scale, almost annual scale. So one more example I want to give you that from the Baratang Island, we have one sample. Through that sample, we found that around 2 kilo year, the delta 18 is showing you some change. So there are a lot of changes occurring. So a lot of changes, it can be interpreted in terms of the change in the past strength of the monsoon. This this slide gives you overall idea to what extent data is available from this country. So there are four groups, active groups. There are some others also. They are working, and then several caves have been explored, and the samples have been collected. They have been processed, and the data is now available. The data covering it goes up to 280 kilo year. Very high resolution annual scale data is also available from here, and also it goes back in time up to 280 kilo year. In the next slide, I want to show you. See the time covered, all these samples, the samples which have been studied in the Indian caves. See it goes from 0 to up to 300 kilo year. The same thing up to 30 kilo year is shown here in expanded manner. So the time coverage, you will see that all the samples, they are not continuously. They have not gone. They have not covered all these things, because why the system may have interrupted their formation because of the random processes or maybe climate-driven processes. So in these kind of studies, the samples which are covered, unless you date, you don't know what was the beginning or what was the end part, unless until it was collected in actively growing condition. That means the water was dripping when it was collected. Now, one piece of information with based on the compilation of the data, it is available in this particular review paper. You will see that during younger dryas, and there are Henrik events, they are all recorded here. During younger dryas, you see that there was a poor monsoon. The monsoon strength was affected during all these things. I want to add here that India, there are different caves, and each location, you know that the prime source of rain is from the Arabian Sea. There some monsoon, some depressions are formed, and sometimes it comes from the Bay of Bengal. Although there are systematic patterns, that means the dominant sources of moisture may be either Arabian Sea or Bay of Bengal, but sometimes there are zones where the mixed constituents are there. So the isotopic composition of this one, the Bay of Bengal, Arabian Sea, eventually, if they are mixed up, then it may go in the something which may be complex in nature, and then the interpretation will make things very difficult when the delta 18 time series for the stalagmites are reconstructed, they are produced. Okay, so here I want to make a comment that verification of a local calibration between oxygen isotope ratio and amount of precipitation is very necessary. Otherwise, just by collecting samples, stalagmite samples, and then measuring with a lot of meticulous work, delta 18 time series will be available. But unless until the whatever things are isotopic behavior in the local rainwater is there, unless it is established, it will become difficult. The interpretations may go in the wrong direction also. I want to tell you that other than this, the other elements like magnesium, strontium, and barium, and then carbon isotope ratio are also used to inform environmental changes, but they are not very clearly defined. Why? Because the chemistry may be different, the constituents may be different, it may be dependent on cave to cave, and also the carbon isotope ratio, they depend on several factors, including the vegetation above, the climate, ambient climate, and then the post dissolution process, like the residence time of water, all these things. So carbon isotope ratio is some way used to support the delta 18, but as such they are not directly used to address the past information. If you are really interested, you may go to these two recent reviews available. It gives you complete summary of the work which has been done in India, and the summary information that it is possible to have very high resolution uh, information about the rainfall, terrestrial rainfall, as far as the Indian subcontinent is concerned, because we have in several places established the amount effect. And for young people, I would like to say that it is a challenging job to collect samples, but then you should also explore new samples, new caves. Unless until you explore new caves, it will be difficult to address the temporal and spatial variability of the reconstructed data. And with this, I thank you all for listening to my talk. Thank you.
Thank you, Yadav sir. It was really
Yeah.
wonderful talk, and I'm sure that most of our PG students who are looking for their uh, career in research, they must have benefited from your talk, and they learn more and more about speleothems, which is new for this generation now. And as we know that, as per the GSSP 2016, the new Meghalayan age has been assigned based on the speleothem record from India. There's one question from a PhD scholar. He's asking, sir, can I know the reason why Meghalayan age, that is 4.2 kilo years, established from northeastern cave deposit, as many caves are in India? Is it a specific reason behind it?
Yes. See, the reason is very straight forward. The reason is that they got a very good sample from Meghalayan cave, and if you recall that I used the word dirty speleothems. Okay, so dirty speleothems, that means you go and find out samples in caves, then you may end up with the dirty speleothem in most of the cases. Okay, we have so many samples, but several of them are dirty samples. So they got a very good sample there. This is the first reason. And the second, they have a you know that the ages, if you are talking about the 4.2 kilo year, so you should be pretty confident that uncertainty should be within plus minus 10 year or so. So if you want to restrict the uncertainty to very low level, then the uranium concentration in the sample in the bedrock zone should be very high. And luckily, it was so in the Meghalayan stalagmite. So first reason is the sample was very clean, it was not dirty. Second, the ages are very well controlled. They have a very low uncertainty, age uncertainty. And third, the sample growth was very high during the whole. I mean, the sample covers. You know that you need some sample for analytical method for stable isotope measurement. So if the sample length is very small, it will be difficult for the analysis. But the sample size is very good, reasonable, then you can do very high resolution stable isotope measurement. So all these things favored there, and then finally around 4.2 kilo year, because the delta 18O is showing abnormal change, and this abnormal change is reconstructed at very high resolution. This kind of information is not available from other places, and this is the reason the Meghalayan age, the terminology has been used.
Thanks, sir. Thanks for your explanation, sir. Because of time constraint, we are restricting the question. We will ask our speakers at the end of ask the speaker the questions at the end of the third talk. In the meanwhile, I will request Dr. Ashutosh Singh from Delhi University to kindly start his presentation. Dr. Ashutosh, sir. Yeah.
Ankush, can you please allow me to join?
Yeah, you are already joined.
No, no,
Yeah,
actually,
yeah, you are here.
I need to present, right?
Yeah,
Present now. Your entire screen.
yeah, that will be easy for us.
And then
Then you just
share.
yeah, share. Just click on the window and then share. So there is some noise coming from your background.
Actually, lots of weddings in my colony. So sorry for that.
Okay.
Present now. Present now. Your entire screen.
Then click on the window and then share.
Share. But where is my slide? Just a moment. Huh?
Okay.
I think my screen is visible, right?
Yeah, visible.
But how can I?
You can just open your presentation and just start presenting because it's
Okay.
your whole entire screen is shared now. You can
Got
just
it. Got it. Got it. Got it. Now you can see my slide.
yeah,
That thing, right?
yes, sir. You can start now.
Okay. Thanks. Uh, good afternoon, everyone. I'm Ashutosh, and Ankush has invited me for delivering this talk. And the title of my talk is Earth, Ocean, and Climate. After listening to Dr. Nigam and Professor Yadav, my job is a bit easy because Nigam sir has already told us about foraminifera and their applications. So I'll not go in detail about planktic foraminifers. Okay, so I'll be talking much about Earth, ocean, and climate. As we know that everything has a past, right? Similarly, Earth has a past, oceans has a past, and climate has also a past. And on the basis of studying their past records, we can predict the future. It means there must be some relationship between the past, present, and the future. So, question will be, how can we decipher or how can we get the idea about the past, right? Past about Earth or even ocean or even for the climatic condition. So, as we know that there is a link between past and present and near future, and then Earth and extraterrestrial object, or even Earth with different spheres like cryosphere, biosphere, mesosphere, cryosphere, and atmosphere, right? And why we need to discuss all these things? Because as we know that the age of Earth is 4.6 billion years, right? And here you can see that. Can you see the cursor?
Yes, sir. I can see the cursor. Sir, can you please close this dialogues box for update?
Oh,
Yeah, that will be fine.
yeah.
Okay, sir. Go
Thank
ahead.
you. Thank you. So this box is representing the Earth, okay? And we here we are talking about the time duration that is 4.6 billion years, and that is why we are saying that this is a magical box because after the origin of Earth and origin of life, uh, mm, from amoeba to us human beings, it took almost 4.6 billion years, and we have to decipher what happened in this box to convert amoeba to human beings. And as we know that evolution, organic evolution, is unidirectional from amoeba to human beings, right? So, and their interaction between each other. And all those records are preserved inside the earths only. just like we are having very interesting books with number of pages, right? And all the pages are well numbered. So we can start reading from page number 1 to the last, right? And suppose what happened? We are having a book, and in that book we are having pages without numbers. And suppose somehow we are losing all those pages, right, here and there. Then how we are going to connect the link? Means initial pages to the last pages. It means we have to find it out the dots or connection between initial pages and the last page. Okay. Similarly, we are doing such kind of work in our research also. Means just like on Earth surface, we are having a sedimentary rock which are having number of layers, and each layers are characterized by certain features. Okay, so by observing all those features, we can find it out the evolutionary trend as well as the link between the older layer to the other layers. Just like suppose I'll ask you that can we see the past? Answer will be yes, we can, right? We can see the past by the help of past records, or even we can say that whatever we are observing during night, the lights, right? They are coming from some stars to us, and they are taking some light years. Means they are having that much of distance from us, and they are not twinkling today. If suppose something happened to all those stars or galaxies, then we can observe all those things after so many billion of years, right? Similarly, on this planet Earth, we are having mountain terrains. Just like Nigam sir told us that once upon a time, whole Himalayas was under the sea. Like in your screen, you can see that Mount Everest, right? And in Mount Everest, we are getting marine fossils, and that is the evidence what Nigam sir told us that once upon a time, whole Himalayas were under the sea, right? Similar kind of research we are doing right now. Here in this cartoon, you can see that splitting of continents, movement of the plates from one place to another place, from creation of the ocean, closing of oceans by collision of two continents, right? And they resulted into creation of mountains, landforms, and oceans. So I told you that my topic will be Earth, ocean, and the climate. So here, one important question is that why to study ocean circulation? Ocean circulation means here we need to study about different ocean currents, right? And we are having two different kinds of ocean currents. One is surface circulation, and second is deep water circulation. And we are having two different kinds of current. One is warm water current, and second is deep water current. We'll discuss in detail later on, but question will be same. What's the need to study ocean circulation? As you know that we are receiving heat from the sun, and the solar heat is not equally distributed because of the tilt of the earth, and that is how near the equator we are getting maximum amount of heat from the sun if we are comparing that with the polar region. And we have to balance this, right? Just like we need to prepare our budget, we are also having the heat budget. Mother Earth is having that heat budget, and to balance that, we are having some ocean currents. Means one ocean current is flowing from equatorial region to the polar region, and second is from polar region to the equatorial region. That is how we are balancing the heat. So they are very important because they are controlling the climatic condition also. How? We'll discuss later on. Just like every year we are talking about two terms. One is El Nino, second is La Nina. Because every year, March onwards, in newspapers, in television news discussion, everybody will be worrying about the fate of monsoon, right? This time we'll have good monsoon, average monsoon, or below average monsoon. And every time we are talking about El Nino and the La Nina condition in the Pacific, they are linked with the current that is termed as Humboldt current. Similarly, we are having two poles, right? Antarctic, North Pole and the South Poles. where we are having ice sheets. And ocean currents are responsible for the development of all those ice sheets. Just like Gulf Stream is responsible for North Pole ice sheet. Similarly, Circumantarctic Current, which is responsible for the permanent ice sheet over Antarctica, and some other currents, just like we are having Levin Current, which is responsible for the warming up of Eastern Indian Ocean, and most importantly, Indian monsoon, which is linked with the land sea temperature contrast and the moisture transported from Western Arabian Sea to the Indian subcontinent, and which will be ultimately giving us the monsoonal precipitation. So these are the links we need to discuss. But before that, we need to ask ourselves some basic questions like why Delhi is hot and Shimla is cold, right? What could be the reason? Why Labrador is cold and British Isles warmer? Why Chennai is so hot, not so cold? And why summers are hot and winters are cold? These are the basic questions we need to answer. And what could be the reason? Just like for summer and winter, why summers are hot and winters are cold? They're just like our spending capability. If we are spending more, earning less, or we are saving more and expending less. So this type of concept is also related with some hot summer and cold winters. And definitely latitudes are also playing a very important role. Altitudes are playing a very important role. And even currents, just like I told you about Gulf Stream. Because of the Gulf Stream, which is flowing in North Atlantic Ocean from equator to polar region, and because of that, eastern coast of North America and western part of some countries of Europe, they are receiving moderate climatic condition because of this warm water current. Before going to discuss in detail, we need to ask some question like when and why did the Antarctic ice sheet cap developed? When and why did the North Hemisphere ice sheet develop? Why did the northern ice sheet form later than Antarctic ice sheet? Similarly, we are having a number of questions, and we need to answer one by one. Okay, but for that we need material, right? Just like Yadav sir told us about speleothems to study about monsoonal precipitation records, right? So for such kind of study, we need archives, natural archives. Just like in this slide, you can see that ice cores from polar regions. Along with these ice cores, we can get the deep sea cores by using different methodology, gravity cores or hydraulic piston coring method. In this, we can eject the sediment from the deep sea. And after processing the deep sea, we can get such kind of organisms. They can be foraminifers, radiolarians, diatoms, calcareous nanoplanktons, anything. Here in this work, we are using planktic foraminifers and benthic foraminifers to find it out the reason for your Antarctic ice sheet development or Arctic ice sheet development. This is your living foraminifera, picture of living foraminifera, and Nigam sir has already talked about foraminifera in detail. I just wanted to add something that they are showing latitudinal provincialism, planktic foraminifers. They are passive dwellers, means they can't swim from one place to another place, right? And Nigam sir told us that they are exclusively marine, right? So they are passive dwellers. So and they are present in different latitudes. As we know that we can divide our Earth into 3 different zones: temperate, tropical, and polar region. And planktic foraminifers are having their affinity for certain latitudinal provincialism. Just like some of foraminifers, planktic foraminifers, loves to be in tropical latitude, means warmer water condition. They want warm water for their growth, for their living. Some of them prefer colder water, and some of them prefers extreme cold water. So on the basis of their distribution, means they are also related with ocean currents. Means their migration is totally controlled by the ocean currents, warm ocean current or cold ocean current. So by getting variation in their abundance from one place can be related with the strength of ocean currents. Okay. Along with this, they're also having depth stratification. We can divide ocean water column into three different main zone. One is mixed layer, second is thermocline layer, and third is deep water layer. And all these three zones are characterized by certain group of planktic foraminifers. For example, very famous GS Ruber. Everyone is using GS Ruber for isotopic analysis, oxygen isotopic analysis, and which is present only in oligotrophic, low nutrient, surface water, warm water condition. While Minardii is present only in thermocline zone, whereas your Crassiformis and Venezuela and other planktic foraminiferal species love to be in the deeper water condition. So we are exploiting all this property of planktic foraminifer to decipher paleoceanographic and paleoclimatic condition. Here in this slide, you can see that retreat of the ice sheet from 18, 14, 13, and you can see the retreat of the ice sheet. And this is related with climatic condition as well as strength of the ocean currents, which is flowing towards north. And this slide is showing the ice sheet over Antarctica. Now we can discuss that what could be the reason for having this kind of ice sheet. In this slide, we can see that major ocean current. The red ones are showing warm water condition. I told you about this Gulf Stream, this Brazilian current, then your somewhere here we are having Levin current, and blue ones are showing cold water condition, cold water current. And I told you about this already, that we are having two different kinds of circulation pattern. One is surface circulation, second is deep water circulation. And this surface circulation can be controlled by a number of factors like wind stress or continent geometry or Coriolis force. And this continent geometry means due to plate tectonics, continents are moving north or south, and because of that, there sometimes we are having opening of gateways or closing of gateways, and they are responsible for the variation in the flow of ocean currents. Just like we are having south equatorial current in Atlantic Ocean, which is flowing towards west, and after having a barrier, that is your South America, and because of that barrier, we are having South equatorial current bifurcated into two. One is going towards north and one is going towards south as a Brazilian current. And second is your Coriolis force. As you know that because of the Coriolis force, any object will be deflected towards its right or left with respect to their hemisphere. In the northern hemisphere, object will be deflected towards its right, while in the southern hemisphere, object will be deflected towards its left. And they are playing a crucial role in maintaining the or in diverting the ocean currents, flow of ocean water currents. And because of surface circulation, we are having certain phenomenon, just like we are having creation of large gyres. Along with that, we are having, because of the surface circulation pattern, we are having El Nino type of condition. I'll discuss in detail afterwards. And this slide is showing about the different zones and their wind patterns. And because of this wind patterns as well as the ocean currents, we are getting certain important phenomenon. Just like here, I told you that here we are having an important current, that is Humboldt current, which is flowing towards equatorial direction, which is flowing towards equator with the effect of trade winds. And because of the Coriolis force, trade wind, this ocean current will be deflected away from the coast, and here we can have the upwelling. Upwelling means deep nutrient rich water will come up, and that nutrient rich water will flourish the growth, flourish biological productivity, primary productivity. And from here the surface water will travel towards the western side, western Pacific side. And here, over here, we are having a very narrow channel, that is Indonesian through flow. And because of this narrow channel, here the warm water will pile up, and that warm water will form uh, Western Pacific warm pool. And this warm water will enter into Indian Ocean via Indonesian through flow, and it will affect the sea surface temperature of Indian Ocean. And as we know that this sea surface temperature will play a crucial role in Indian monsoonal development. And basically, I wanted to discuss this ocean continent geometry. I told you that because of movement of the continent or separation of the continent, we are having a creation of gateways. And because of this only, we are having ice sheet development over polar region. First, I'll discuss with you about Antarctic ice sheet. Here you can see that Antarctica was joined with South America, and with due course of time, we are having, and here you can see that we are not having any opening over here, and but with due course of time, both the continents separated from one another, and because of this, we are having opening over here, and water is start moving like this, and then opening from this side, direct Tasmanian Seaway, we are having a circulation all along Antarctica. Okay, and because of this, we are having thermal isolation of Antarctica, which helps in the formation of permanent ice sheet over Antarctica. And we got to know about this, all this history, all this story by the help of small creature, benthic foraminifera. Okay, we got some core from here to here, here, and here, and by observing all those benthic foraminifers, we track the movement of ocean water currents. And on the basis of that, it was suggested that because of the thermal isolation of Antarctica by the help of circumpolar current, Antarctic circumpolar current, we got permanent ice sheet over this. And that current provided moisture also for the development of the ice sheet over Antarctica. Similarly, here you can see that a channel between Atlantic and the Pacific Ocean, and this channel is termed as Panama Seaway. And because of this, the current which is flowing towards north is also supplying water to the Pacific Ocean from Atlantic. So the current, the strength of that current is not that much because of the less supply of water. Because here we are getting water entering into the Pacific, also moving towards north. But what happened? Due to the closing of this Panama Seaway, due to Panama Isthmus, whole water is moving towards north and supplying huge amount of moisture to the Greenland region of Arctic region. And because of this, transport of moisture towards the polar region, and after the precipitation, snowfall, ultimately with time, formed a permanent ice sheet over North Pole region. And because of this forming of the ice sheet over Arctic region, we got thermohaline circulation. Here you can see that ice sheet over North Pole. And because of this, as you know that water is moving towards polar region, and over here, due to the freezing of water and creation of ice used to reject all the saline material, that is termed as brine rejection. Because of this, the density will increase and the water will sink, and this water will move towards the equatorial region. And over here near the equator, that water will come up as upwelling, and that is how we are having creation of deep water circulation and our great ocean conveyor belt. Means we are having the warm water which is moving towards the polar region, and over here this is the area where this water will be converted into the ice, and ice will reject all the haline or saline material, and because of that here we are having the sinking of the water or deep water creation, thermohaline circulation, and this deep water will move. And here also north of Antarctica near the Weddell Sea, again we are having the region where deep water is forming, and then it will move towards the Pacific Ocean. And that is how we are having this great ocean conveyor belt. And this ocean conveyor belt or ocean currents are playing a crucial role in our climatic condition. That is all from my side. I just wanted to tell you about ocean circulation and their link with climatic condition, ocean currents, and their role in formation of permanent ice sheet over both the poles. That is all from my side. Thank you.
Thank you, sir. Thank you for your wonderful talk. It was really wonderful to listen to your talk, and it gives a totally different perspective to our students who are looking forward for their career in paleoclimatic research. There's one question from Nabankur Majumdar. His question is, what are trade winds, and why do trade winds and strong equatorial winds normally flow to the west?
Ankush, can you please repeat the question?
What are trade winds,
Mm-hmm.
and why do trade winds and other equatorial winds flow to the west? Yeah, this one.
Actually, trade winds, the term trade came from the actually initially when we were not having motorized ships, we are using the wind power for our ships. So from where that come trade with this wind system, and why they are moving towards
West,
west
closed.
due to Coriolis effect, due to Coriolis force.
Thank you.
And as we know that winds are moving from one direction to other direction because of the pressure gradient, right? Variation in the pressure gradient, high pressure to low pressure area. And when any object is moving, then definitely that object will experience the Coriolis force. So when winds are moving from, say for example, here you can see that if winds are moving from this place to this place, means from this latitude to horse latitude towards the equatorial region, then they are bound to be deflected towards west because of the effect of Coriolis force.
Dr. Singh, there is another question from one of our students, PG students. He's asking how El Nino and La Nina affects Indian monsoon.
Okay. I told you that during my discussion, I told you that warm waters from this region, they are continuously transported towards this direction, right? So here we are having warm water condition, and due to upwelling, here you can have cold water condition. This is a normal condition termed as La Nina. And during La Nina condition, the warm water will enter into the Indian Ocean, and that will affect the sea surface temperature of Indian Ocean. And that is how we are having that will help in the formation of Indian Ocean. And suppose opposite of this case, because of the weak trade winds, because as we know that El Nino is a quasi-periodic event, so we can't get the periodicity in this. So because of the trade winds, why? Here, if you are having a weak trade winds, then Humboldt, the effect of trade wind will be very less on the Humboldt current. So water will not be deflected much away from the coast. So upwelling will not take place in this region. At the same time, what will happen? Here, the piling of warm water will be quite high, and there must be some threshold, right? And after crossing that threshold, this warm water will move towards this direction also, right? So this whole Pacific Ocean, equatorial region, will be quite warm, and at that time, the less amount of warm water will enter into the Indian Ocean, and at that time, you can see that the sea surface temperature of Indian Ocean will not be that much. What we are observing during La Nina condition. So that is why we are saying that La Nina is helpful for our Indian monsoon condition in comparison to the El Nino condition. If you want to know more, we can discuss.
Thank you, Dr. Singh, for your answer to the queries. Now, I will request our organizing member, Dr. Anjali Singh, to kindly unmute all the participants in this Google Meet platform. And if they have any queries, they can ask the speaker. Dr. Singh, Dr. Anjali Singh. Okay, so there are a few questions for Dr. Rajiv Nigam sir. Nigam sir?
जी बोलिए.
Sir, there's one question from one of our undergraduate students. She's asking why Dwarika can't be visited with the means of underwater tourism.
Underwater?
Tourism.
See, first, see, this question has been asked by the Transport Ministry couple of times. It's not that you go under the water and you will walk into the a palace and you can see the Krishna's bedroom. See, there are ruins of an ancient city. Okay, the ruins. See, if you see on the land, anywhere you go and see the ruins, you will get only the foundations. Hardly you get anywhere the full buildings. Now this is 3,500 year old into the sea. So some places only you get the foundation stones, and moreover this is a very rough sea. We could get time for field work for diving only few weeks when their water is very clear. So that's why we have not said that put a tube, but rather we recommended that a diving program in a fair weather season can be arranged where tourists can go down and see those ancient ruins. Some stones which is arranged in a like a wall-like manner. This is what is Dwarika. Actually, more than that, a museum at Dwarika will be encouraged. So whatever has been recovered from underwater Dwarika should be stored at one place, and seasonal scuba diving can be arranged.
Okay, sir. Then there's one more question from another student from
Yes.
IIT Bombay. He's asking how prolocular size is related to salinity.
Okay. See, this phenomena is associated with the dimorphism. Okay. With foraminifera reproduce in a dimorphic way sexually and asexually, and resultant forms are told microspheric or megalospheric. The one which is found by sexual reproduction microspheric, it is having a small proloculus. Okay. And those who form by asexual reproduction have a larger proloculus. Now, this phenomena is temperature dependent. So, when there is extreme climate, then microspheric reproduction will be more. So, if specimen with a smaller proloculus will be more, mean proloculus size will come down. Now, this climatic factor is sensitive. So, we have two papers. One is in the Paleo 3 in 1986, And another paper is with the Aradhna Rao in Assurine Coastal and Shelf Sciences. Year I don't remember, where you can see very, and one is there into the uh, Proceeding National Academy, Indian National Science Academy. Okay, I think that was in 82 or something, where you will get a full picture. So it is and this, because of this, we have gone for the culturing. Now it is proved that yes, dimorphism is climate dependent, and therefore, see, either you can go for dimorphic ratio, megalospheric versus microspheric, but sometimes the size of proloculus variation is so much, it is not very easy to differentiate which one is microspheric and which one is megalospheric. So therefore, we converted it into mean proloculus size.
Okay, sir. There is one more question for you. Uh,
Yeah,
it's from one of the faculty from Bhopal. He's
yeah,
asking, he's from mines and new to foraminiferal field.
yeah,
He's asking, as you said in your talk, that conodonts no more exist now. You mean they are
yeah.
not found anywhere globally?
See, these are the extinct fossils.
Okay.
These are phosphatic fossils. They are not living. And till today, it is not very sure they are remnant of what animal. That's what I read in the literature. I myself have never worked on it. But conodonts, mm, Dr. From Lucknow University, Dr. Nandalal Chabra, his PhD is there. And I think Dr. Azmi also has for
Worked on.
some time worked on conodonts.
Yes,
Yes.
sir.
So these are the two
Masuri
experts on
phosphorite.
conodonts, besides Professor Ashok Sani, who is a well-known paleontologist working on many other branches as well.
Okay. He have one more query. He's asking, he worked in Khetri copper mine and had collected rainfall data from 1987 to 2010. He find a rising trend in rainfall pattern. Is it found in other desert places too, or unique to Khetri? Is it heartening to note or indicative of something else?
See, I will prevent myself to generalize my finding because that has been done from the Arabian Sea side. But one thing is there, if rainfall has been controlled by extraterrestrial effect, okay, by the variation in the incoming energy from the sun, this effect should be seen everywhere. The magnitude may differ, the league or lag may be there, but effect of cycle should be there. And according to me, the effect of cycle is that we were going through an average. When I say good rainfall means the average, decadal average, because in our experiment, the resolution was 8 years. So I cannot talk less than decade. So decadal rainfall, if he's getting a good rainfall, then it means he's agreeing with what we have published for the Arabian Sea region.
Thank you, sir. Uh, if any of member have any query, they can ask our speakers. I think there is no more query, and I
I
really
have seen one more question was there in the chat section of YouTube.
yes, sir.
That what about mythological
Yeah, 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 sir.
Dwarika?
Yes, sir. Yes, sir.
So
She's asking, are the mythological assumptions and importance of Dwarika can be accepted?
say it was very difficult till we get uh, work done by Sarosh Bala and some others about timing of the Rama. Because I remember many people were asking me about my opinion about Ram Setu when this was a controversial problem. Now, I said I don't know when the what is the time of Rama. If you tell me, I will tell you what was the sea level condition and Ram Setu was possible or not. Now, what this group has done in Delhi, they collected the position of stars at the time of Rama's event. That position they fed into the planetarium software. and check when that combination was there. Okay. Now they found that it is something around 7,000 years before that. Now, if that is true, it matches very well that Ram Setu was a reality. It was not a myth. Neither it was an imaginary thing as some people may try to make it. Because that time sea level was about 2 to 3 meters lower than present. And if you lower the sea level by 3 meters, India and Sri Lanka almost get connected, except few ditches in between, which can be filled with whatever material, stones, trees, dust, whatnot. And it was not a setu. Okay, setu means like a flyover. It's a bridge, overhead bridge. There is Sanskrit, what we call it, setu bandh Rameshwar. It is the bandh. It is the causeway. Okay, जैसे गांव में देखा होगा ना, during the low rainfall time, people cross the river by putting the stones. So it was possible to cross over to Sri Lanka by this way. So this is not a myth. Shri Krishna, now the new research which is coming, which is telling that probably they were the historical figures, these were the realities. Because Dwarka, we found a submerged Dwarka, which was earlier only in literature. Now, good evidence is there. Now we found that timing of all the things are indicating there is a scientific proof. It's not only mythology. Three more questions. If anybody wants, if Ankushi, there is no more question.
Yes, sir. There's no more questions.
Okay, thank you so much, sir.
Yeah, Anjali, you can
Okay, so
continue.
thank you very much. I really thoroughly enjoyed all the three school lectures by Dr. Yadav and Dr. Ashutosh. Both were wonderful lectures. Of course, Dr. Yadav is a very senior person, but Ashutosh, you have done a wonderful job.
Thank you, sir.
Congratulations. Keep it up.
Thank you,
Dr.
sir.
Yadav, the lecture was very informative. I just wanted to ask one question.
Yeah, please. Thank you. Yeah.
Where this proxy takes over the other proxies. Uh, in certain conditions, there must be some benefit, like tree rings have their priority in certain areas. Foraminifera have priorities in some other areas. So, what are the speleotherm can give you a data? See, we generate the data about past monsoon record from various proxies. So, I want to know, is there any typical condition when speleotherm is the best to answer?
Yes. Time coverage. For example, the clearings. The clearings can so far in from Himalaya, people have gone up to hardly few centuries. In some locations, they have gone. Some samples have been collected, which goes up to 800 years or so. So it is the time which is important. Whereas the speleothems, you know that it can cover the whole Holocene if right samples are collected.
Yeah, because Holocene also tree rings work of that Yadav from BSIP. I am aware of it. Or GB Pant
Yeah.
group also work on tree rings. But and what are the limitations where we should
Yeah.
not use it?
No, the limitation is the availability of the long records. Trees are not available. Samples, I mean, you need the samples to cover several hundred years. So that is the main limitation. Whereas speleothems, they can go as long as, I mean, if you are able, you are lucky, you are collecting a good piece of stalagmite, it may cover the whole Holocene. So that is the advantage.
Thank you.
Yeah.
Okay, thank you so much, sir. Nigam, sir, thank you so much for your quick and thoughtful responses to resolve the queries of the participants. And also, thank you so much, sir. Thank you so much for quick response. And now I invite Dr. Ankush for vote of thanks.
Thank you, Dr. Anjali. It's it was really a wonderful experience to have our speakers here and share their experience with our students. Sir, it's a great honor and privilege to propose the vote of thanks on this webinar. Let me first of all start by giving glory to our Almighty God for making today's webinar a resounding success. First and foremost, I thank our distinguished speaker, Dr. Rajiv Nigam sir, former Deputy Director and Emeritus Scientist, National Institute of Oceanography, Goa, who, despite of his busy schedule, has found time to agree for this webinar. I also express my heartfelt thanks to Professor M.G. Yadava sir from Geoscience Division Physical Research Laboratory, Ahmedabad, for your valuable talk and guidance to our students in the field of speleothems. I also express my deep thanks to Dr. Ashutosh K. Singh from Department of Geology, Delhi University. I'm sure that his talk benefited our students, and he very soundly prepared, told students about tectonics, climate, and ocean linkage. I thank our Honorable Vice Chancellor, sir, Professor Amrika Singh, for his unstinted support and idea about organizing this webinar on today, that is 27th of November. I also express my thanks to our professor and retired professor who was here on this platform, Professor Harsbu sir, for his valuable contribution, guidance, and encouragement. Uh, I owe a special gratitude to our co-convener, Dr. Anjali Singh, our organizing secretary, Mr. Akhil Kumar Dwivedi, and Mr. Niranjan Mohanty, who have worked hard to ensure that this webinar becomes a memorable success. I thank all the distinguished invitees present here, accepting our invitations. I thank all the participants from different institutions, states, and from different countries. Without their participation, this webinar would be hard to imagine. Last but not least, I would thank you, my friend, for your cooperation in making this function as a resounding success. Now, I would like to take permission from our dignitaries present here to end this program.
Give a big hand to Ankush and his team.
Thank you so much, sir.
Welcome.
Okay, sir. Thank you.
Chalo, bye-bye.
Okay, sir. Bye, sir.
Bye.
Bye, sir. Bye, sir.
Bye, Ashutosh. Okay, Ankush, well done.
Bye, sir. Thank you, sir.
Thank you. Bye.